Welcome, Nikhil, to Docents. Thank you so much for doing this. I'm so happy that we're doing this.
Thank you for having me. I'm super excited.
Yeah. So for those who are watching, I'll just give some context on what is it that we're doing exactly. Monica and I have a podcast called Docents. You obviously know that, but I'm going to act as if you don't know about it, just so that everyone also has context. So during our free time, we do this podcast where I'm like endlessly curious about like a lot of things in the world. Monica reads a lot, and she basically explained those things to me. So like the structure of Docents is we have a podcast around this topic of big history. And the idea is like you have to start. If you have to start your educational journey, you have to start somewhere. And we started with big history, which basically explains like the history of everything. And like everything is a big word, right? Like, but it literally encompasses everything. So it starts from the Big Bang, and right up from Big Bang, which happened like 13.8 billion years ago. How did it all come to here? Like we're living in Silicon Valley, which is like the, in some sense, which is like the peak of human civilization right now. So how did we come from atoms to like evolution? So like that's the idea. We have done about 23 episodes so far. And the general idea with Docents is that she will, in every episode, she will explain a topic to me. So recently, I mean, we haven't recorded for a while, but recently I've just been so fascinated with all of the developments that's been happening around AI. You and I have talked about it a lot. I mean, for also those of us listening, that you and I are good friends, like we're the best of friends. We're childhood friends. We have known each other for the longest time. I feel like we have amazing conversations. So I invited you because you know this technology pretty well. And the main goal is I just want to understand how it all works. So
basically, I'm Monica in this episode.
You are right? Monica in this episode.
Sure.
Monica is taking care of our child right now.
Which is the reason why you haven't recorded a podcast
Exactly.
in a while.
We had a baby girl, which we're really happy about, and it's been hard to record. Actually, another reason is that I'm hoping with this we'll get motivation to start recording again sometime soon. So yeah, you said it right. You're Monica in this episode. And the simple idea is I've been playing around with ChatGPT like almost everyone is around me, like this technology which is sort of blown up around us. And it's not just ChatGPT. It's like I've been playing around with Midjourney, and it almost seems like magic to me. Like when I talk to ChatGPT, the way I think about this is it's as if I've talking to the smartest person I've ever talked to in my life. Like ChatGPT knows everything about everything, and it's about to give me advice in a lot of things. Like for example, this is probably not a good place to be seeking such advice, but I was like, oh, my baby girl has turned 6 months old. I want to start feeding her solid food soon. Can you help me think through like what are some considerations? Like the idea is I do a lot of these things. Like, can you help me think through? And it'll like come up with really good answers, and it'll get me started.
Yeah.
I've been playing around with Midjourney. I'll give it prompts and it comes up with such fascinating images. So to me, it just seems like magic. Like this is magic. Like I don't think I have been this excited about any new technology. Like I remember like the only time I was this fascinated by a technology is when I first discovered the internet. It's like, whoa, I could just like log into and like get access to anything under the earth. So I really like the magic part, but I want to understand like the trick behind the magic. So can you like play the magician who spoils this trick for me? Like, can you give me a look under the hood? What my goal from this is, like in our conversation, I want to really, really, really understand how this technology works. And I know like it might be hard to do it in a conversation, but like even if I can understand like at a fundamental level, like what empowers all of these technologies, that'll be like a good win for me out of this conversation. Like that'll be a good
so I think what I was hoping to cover is ChatGPT is super exciting right now. There's a lot of possibility with ChatGPT and language model powered applications, but maybe we can take a step back and think about some of the fundamental building blocks of AI and machine learning, and that's something I can help with, and we can go deep into how does machine learning work, what are models, how are they trained, and then probably we won't be able to get into how was ChatGPT trained. Maybe at a high level we can look at that, but we can build up some of the foundation of what models are, how they're trained, and build some intuition behind how a system like ChatGPT works.
That's amazing. That's actually the perfect reason why you're here, is because I don't even know what I don't know. So like I want to learn how ChatGPT works, but all of the things that you described, models, how they're training, like I want to understand the basics of like what is a model even, like what does it mean to train a model, right? And because I don't know what I don't know, I don't know what are the things that I need to know. So you actually, I think, put it right. I want to understand the fundamental building blocks of this technology that ultimately powers something like ChatGPT. And maybe if I understand the fundamentals, I'll be able to appreciate this technology and also see like what are the other possibilities with this technology, what are some of its limitations. So yeah, like without much further ado, like why don't you take it away and help me understand like the building blocks of eventually what leads up to something like a ChatGPT.
Yeah, sure. So I think I prepared like a couple of topics that I want to cover, and let's keep it interactive. Like whenever we go through a topic, keep asking me questions about it. I'll maybe give a brief introduction to what this topic is, and you can keep asking me questions, and we'll have an interactive back and forth. But what I was planning to cover is basically what is artificial intelligence? What is machine learning, which is a specific subset of artificial intelligence, and then another subset of that is deep learning and neural networks, and we'll cover those in some detail, and then look at some applications of those, which is language models is one of the applications.
Can I make a request before we jump into it? Can you maybe, just for the audience, I obviously know all this and it might be a bit weird for you, just give a small introduction, like about like how is it that you've come to like understand this technology so well?
About
like
myself.
A little bit of a background on you. And I'll tell you the reason why I've invited you.
Yeah.
The reason why I do this podcast with Monica, let me start with that first, is because Monica is my favorite person to have a conversation with in this world. So I was like, hey, why don't we record it? Like we have so much fun. And I think that that's what I like about you. Like I also really like conversing with you. Like we've been conversing for the last more than 10 years, I feel. And it's always been great conversations.
Almost 20 probably.
Yeah. Actually, decades. And so it's one, I really enjoy having conversations with you. And two, I think you're like one of the smartest persons I know. Like I really think you're really, really smart. And like specifically what I really like is one thing I've noticed is you really, when you understand something well, you have a really good way of explaining things. And I think you explain things simply. And I think that's a really good a test to see if someone understands something well. Because in the past also, like whenever there's been some complicated stuff, I've seeked your advice and you've done a really good job in explaining that to me simply. So like that's why I invited you as a special guest on this podcast. So why don't you start with a little bit about your background? And
okay. Yeah, well, first of all, I'm honored. This is a lot of hype, so I hope I can live up to some of this expectation at least. So yeah, we know each other since, I was just thinking, we met back in 2001. That's when I moved back to India. I was in the US and I joined high school in Hyderabad. So now it's been 22 years.
You're my oldest friend.
Yeah, a lot more than 10 years. Anyway, since then, so we went to high school together. And then after that, I went off to the US and I studied philosophy, and I specialized in an area of philosophy called logic. Then I went on to get a master's degree in logic. And we'll talk a little bit about logic and how that's actually one of the foundations of AI. So that's how I originally got interested in this field. And then after that, Originally, I wanted to go deeper into that and get into academia, but I left that and joined the business world instead. And then I went to business school more recently and started taking some courses in computer science and machine learning. I was at Yale for business school about 5 years or so ago. And that kind of reignited my interest in the modern methods of AI, which is machine learning. And this was the time when GPT-2 had just come out. So I was taking a course in machine learning at Yale in specifically language models. And that was just when GPT-2 had come out, and it was...
sorry to interrupt you. At some point, I would want to get into like, what the hell is GPT-2?
Yeah, absolutely.
Sorry, but go ahead.
So it was just a watershed moment in AI. It was like one of the most powerful like models that we've ever seen. And that kind of ignited my interest to go and work in this field. And I decided that, hey, I want to pivot my career and work in tech and work specifically in the field of artificial intelligence and machine learning. And then, so since graduating from business school, I've been working in the tech industry. Functionally, I'm a product manager, but in terms of like the types of products I work with, they've always been machine learning and AI-based products. I spent about 3 years at Adobe working on enterprise and consumer machine learning applications. One of the coolest things I worked on at Adobe was the Adobe Acrobat mobile application. So, reading PDFs on your mobile device is like a real pain in the ass.
Yeah.
Like you have to pinch and zoom all the
Yeah.
time. And we built this capability called Liquid Mode, which uses machine learning to understand the structure of the document that you're reading, and it converts it to a
Simplified mobile view.
yes, a mobile responsive HTML style document, so you can read it easily.
That's cool. I didn't know
Yeah,
that.
it's actually really cool. I'm plugging Adobe right now, I guess, but if you have to read PDFs, it's one of the best ways to do it on your mobile. And then about a year ago, I moved to Meta, also known as Facebook, which is where I currently work. I work in the ads AI team. We are the team that builds the models that personalize ad experiences. So the models that help understand which ads are most relevant to which users. Yeah. So that's my history with AI and machine. Oh, also like along the way, I got a part-time master's in computer science when I was working at Adobe, and I dug deeper into machine learning and AI in that time. And then right now, ever since ChatGPT came out, I've been really fascinated again with language models. I participated in a hackathon project at Meta where we built an application that generates short form video scripts for you. So, Meta right now is trying to get creators on Instagram Reels, and because we have heavy competition from TikTok. So one of the ways we're trying to do that is we're trying to make it easier for creators to create short form videos on Instagram. And so
what is that hackathon?
A hackathon is a common thing that happens at tech companies, also at universities, where basically you, in a very short, condensed period of time, like anywhere between 2 days and 1 week, you make a small team and just build something. You just don't think too much about what it is you're building. Don't do a lot of detailed product spec and get leadership approval and all. It's just a way for you to get your creative energy out there and build.
Anyone could be in a team. You don't have to have people from your existing team.
Anyone can be in a team, and companies encourage that. So you can take 2 days off of your current day-to-day job responsibilities and go it's a way for companies to generate innovation and new ideas. And so I was able to do something new. I'm a product manager in my day job, but I was doing prompt engineering for this hackathon, and I was writing code. So yeah, and also at universities, it's a way for students to get exposure to building applications and actually doing things rather than just like theoretical learning. So,
it looks like I picked the right person for the job to explain to me all this. The other reason why I'm so motivated to do this is like I've had a decently successful sales career, and one of the things that has been like a core tenet is I also sell technology. Like I work for Google, I sell Google ads, and I feel like anything that you have to sell, you have to profoundly understand what that thing is. And ads, you work in the ad space now, and you would appreciate how complex this world is. And I feel like I have a decent understanding. But I just feel like with this, the more I try to understand it, like more new things keep coming up, and I just can't seem to keep up. So based on what you've explained, I feel like I picked the right guy for the job. And yeah, let's
I
dive into this.
I made some notes here. I might refer to them every now and then. So do you want to get started?
Yeah, let's do it.
So I think the first thing I want to talk about is what is artificial intelligence? And like one definition I looked up is that basically it refers to computer systems that are capable of performing tasks that typically require human intelligence. So like anytime a computer program can do something that you think requires human intelligence, that's what we call AI. And it's a pretty vague definition. Because would you call a calculator AI? Like initially, probably, yes, you would call a calculator AI. Before we had calculators, people would have considered that to be AI. But the moment like that becomes easy to do, that's no longer considered AI. So it's kind of always like a moving target. Every time something becomes easy for computers to do, people start thinking that's no longer AI, that's just normal like computer program. Like even if you think about like computer games, basic computer games that we have, when you interact with computer opponents, like maybe there's a car racing game and there's a computer that's racing a car, that is AI. Like the computer is driving the car on the game. But today, like we don't really think of that as AI because
so you're trying to say that AI has been here for a while. It's just that it's like in our general consciousness, the word AI is like been increasingly popular recently. But like in some sense, AI has been around. Like all of these things are AI.
Yes, and if you go far enough back, you can think of any kind of technology, as in some sense AI, like before we had calculators, we probably had like an abacus, and the old like thing that you move beads on, like that's a rudimentary form of AI. So it's just a matter of advancement, and I think it's always a moving target. AI is always referring to the next big thing that computers can't do right now. So anyway, we're right now going through like a revolution where AI programs are doing more and more than ever before. But I think it's helpful to break down the different like approaches to. So before we think about machine learning and what machine learning is, let's just think about two broad approaches to how AI can be approached.
Yeah, I mean, what is machine learning in relation to AI? First of all,
machine learning is a particular approach to AI. That's basically it. Like AI refers to doing any tasks that require human intelligence.
And machine learning is one of the ways to make...
is one particular approach. And in fact, there's a nice graphic that I found that explains this, which is AI is this big thing. There are two broad approaches to AI. There's what's called rule-based systems, and then there's what's called machine learning. And we can go into the differences between the two. And within machine learning, a subset of that is neural networks, and deep learning is another subset of that.
Yeah, I've heard all of these terms, but I mean, it was like, okay, these are some things about AI, but okay. So these are all approaches to...
These are approaches, and you can see the relation here of which is a subset of which one and which is mutually exclusive. And everything that today is really popular, ChatGPT, Midjourney, what you were talking about, most modern applications are within this little deep learning circle over here. So that's the approach that's become most popular.
So are you saying like if like this is the stuff where I have been super fascinated, and to understand this and to fully appreciate it, it's like the approach I should take is to understand how we came to this?
Yeah, I mean, I don't know if like that's the approach you should take. If you want to understand the general foundations, yes, that's how I would.
Yeah, I like that. Okay.
Yeah, I mean, there are also other approaches to this. Like for example, one of my favorite AI educators, his name is Jeremy Howard. He has a course you can take online. It's called Fast AI. And he has the opposite approach. He's like, he has a course that starts with deep learning. He says, forget about understanding all this stuff. It's called Practical Deep Learning for Coders. And he just gives you some high-level Python libraries that you can use to start building deep learning applications right off the bat. So that's one approach. I think if you want to go and build something, that's a better approach. If you want to understand things, like it's useful to have some theory.
Yeah.
So one thing... Before getting into machine learning, it's useful to think about this distinction. In the early days of AI, like until about the 1980s or so, the rule-based system was the most popular approach to AI. And to understand the difference between these two approaches, we can consider a simple example of an AI task. Think about spam filtering. So one common AI task is spam filtering. So you get a bunch of emails, and the goal of this task is to classify emails into spam or not spam. Okay, and you can take two approaches to this. One is the rule-based approach, and one is the machine learning approach. In the rule-based approach, what you're trying to do is handcraft specific rules that the program will follow to determine whether an email is spam or not. And you might have rules that, hey, if it doesn't have a subject.
Yes. But I understand what you're trying to say.
It could be like
something, then it's a spam.
It's basically a series of like if-then clauses. It's a logical structure. You can say if it has the word lottery winner in it, if it has the word
Nigerian prince.
Yeah, exactly. Classify that as spam. Otherwise, it's not spam. So that basically the original approach to AI was building increasingly complex rule-based systems to do these kind of tasks. So going back to the computer gaming example that we talked about, like if you want to drive on a racetrack, you can program explicit instructions and say like, if you are, check all these conditions. If you're this much distance away from the wall, if you're this much distance away from the racer, then accelerate, otherwise brake. But giving very explicit rules, that is the rule-based system. Whereas the machine learning approach is something completely different. That's where you said that I'm not going to define the rules. I'm going to let the program discover the rules based on a bunch of data that I'm feeding it. And we'll talk about how that works, but at a high level, that's the distinction between these two approaches. And the rule-based system is what I spent a lot of time studying when I studied logic. That the original approach was that we could get smarter and smarter AI systems by making smarter and smarter rules and understanding the world better. But it turned out that approach kind of hit a dead end, and it didn't have that much power. And the machine learning approach is really what gave AI systems a lot more power.
Right. Yeah. I remember I was watching, like, back when, I mean, it's not that AI has been popular in all of our general consciousness only very recently. It's been like 5-6 years.
Yeah.
And I took my first attempt like maybe 5-6 years ago, and there was a very nice explainer video by like one of the Google associated channels, and they were trying to explain exactly this, is like, how does machine learning really work? And the example they took was, imagine if you had to create a program that identifies oranges.
Okay.
There are two approaches you can take. One approach is a rule-based approach where you say, if the color of the thing that you're seeing is orange, and if it's round, and if the texture is like a little grainy, then it's an orange. But hey, imagine what happens if someone submits a photo of a black and white orange. Like, we as humans would be able to identify and say it's an orange, but your program has just failed because it doesn't meet your first rule that it should be orange in color. And that's a problem with rule-based approaches. Like, you'll always find some area where like one of your rules fails, but like we as humans don't have those like rigid rules.
So absolutely. The world is just too complex. Like, even in the spam example, the original approaches were like they would filter out keywords.
Correct.
And then you say that, okay, like $1 million lottery is filtered out. But what if I'm just genuinely writing an email to you?
Imagine missing out on $1 million because you actually...
Or it could just be that I'm making a joke. I'm like, hey, I read this article about $1 million lottery. It could be any number of things. But yeah, it's too complex to like model. And these systems have always failed.
Right. As the complexity increases, rule-based models hit a plateau sorts. Okay.
Yeah.
That makes sense.
So one good way to think about what is the difference between machine learning and rule-based systems is this diagram, actually, which I really like. I saw it in one of my machine learning classes at university, and it really helped me understand what is machine learning. So in classical programming, which is the rule-based approach, what you do is you create a program, you feed in the rules and the data, and you get the answers out of it. The answer in this case being like spam or not spam.
Right.
Okay. But in machine learning, what happens is you feed the data and the answers into the machine learning program, and as the output, you get the rules. So that's like the key difference between these two approaches. In one case, you are explicitly providing the rules. In the other case, you're providing the answers and you're getting the rules as an output of that.
Right.
So that, I would say, is the key difference, where you're saying, I'm not going to try to learn what are the rules here, what distinguishes spam from not spam. I'm just going to provide a bunch of data and let the system figure out what are the underlying patterns in that data.
Right. And I mean, the ultimate goal in both scenarios is actually to get to answers, like, because the ultimate goal is to provide an input to the system and be able to determine if like put it under a model and see if you get an answer or not.
Yes. I guess you could make a distinction here between, within answers, you can say like known answers and unknown answers. So in the machine learning terminology, we call it training data and validation data. So like, training data is like what I train the model on, and then I have to go and test or validate it on data that it hasn't seen before. So, I might have a set of like maybe 10,000 examples of spam and not spam emails, and that's what I'm calling answers here. But my ultimate goal is to go and use this on emails that have not yet been written, emails that are going to be written tomorrow or next year, and apply the same rules to those emails.
Right.
And
that makes sense.
That's the ultimate goal. I think then we can talk about some of the basic concepts of like what is a model to start with, like, because the output of like ultimately with a machine learning system, what you're going to get is like a model that will predict new answers for you. And the definition of a model is basically it's a representation of a system or process that can be used to make predictions. That's ultimately what you're trying to do, make predictions about the future.
So if I understand the way you're going through this correctly, so what you said is somewhere in the 1980s, folks realized that the classical programming approach hits a wall. And if we need to make advances in computer science or just advances in our original pursuit, which is to make our systems more human intelligence, then we need to take a different approach. And that approach turned out to be machine learning, is what you're saying. Okay. So now advances started happening in the machine learning field. So the genesis of this field was somewhere in the 1980s, and so we'll get into that now. Like, what are some...
Yeah, and most recent advances, neural networks and deep learning have seen the most advances in the 2000s in this century, and particularly in the 2010s, I think, because the scale of computational power and data that's needed to make them very useful has only recently emerged. And before getting into neural networks, let's talk about, I'll start with what I would call classical ML. That's like machine learning that works pre-2000, let's say. It didn't need a ton of data and a ton of computational power.
So, and you're saying to understand that, even the classical ML approach, you have to first understand what training data is, and then I think you were getting into what...
or like, what is a model to start with?
So let's start with that.
I came up with a list of like, what are 5 components of like what a model is.
Okay.
So these are 5 things. This is a simplified view. There are probably more things, but you need to know what is the model architecture. And you need to know what are the features of the model. And then the model will have parameters. It'll have an objective function, and it'll have a training algorithm. And if you have all these 5 things, you have a model that you can use to go make predictions about the world and go, predict whether an email is spam or not spam, or whatever task that you want to do with it.
You're saying ultimately a model is a prediction-making engine?
Yes.
Okay.
Yes, it's a prediction.
That's a good way. Okay. Yeah. Okay, I understand. And then these are the components typically that go into building a model. Okay.
And so I think I wanted to start with a simple example of a model. One of the most simple machine learning models is called linear regression. We can start with that, and we'll take a
very scary sounding name.
But it's
can you make it like accessible for me?
So this diagram, I think, does a pretty good job of making it accessible to you. It's just basically a line. It's a line on an XY plane. That's what regression is. So basically here, what you're trying to do is, the task here is to predict the price of a home.
Okay,
that's the task. You're like given a home, predict the price. And
what do you mean given a home? Like I see a home?
Usually you would have a data set with a bunch of houses listed on it, but you could think about it as like Zillow, right? How does Zillow work today? When you go on Zillow or Redfin or any of these apps,
if given certain features about a home, can I predict the price of a home?
Zillow will give you this thing called a Zestimate, right? It tells you what it, and the Zillow Zestimate is way more complex than what we're going to talk about here.
It's also absurdly wrong or whatever. It's we can get into that. I have a conspiracy theory is that the Zillow estimate actually ruined the real estate market for everyone. Zillow estimate and the Redfin estimate.
Okay.
Yeah. Anyways.
Okay.
We don't have to
we can talk about that later. Or maybe we can talk about it after this example. I'm curious why you think that.
Yeah.
So in this very simplified example, there's only one feature we're using, to predict. And this feature is called number of rooms. So just assume it's very simplified. We say there's just one feature I use, and I'm going to predict how much the house costs. It's probably going to be inaccurate, or maybe in a world in which you restricted it to like, I'm only looking at homes within a certain area where all other things are fixed, you might say that
I agree with you. I think like if you had to take like one thing as a predictor of the home price, like one basic thing to start with,
you pick square footage, or
it's not going to be right, but it's a good indicator.
So the only reason I picked this example is to like explain like what these things mean here.
Got it.
So model architecture, that just means like, what is this model? It's like the underlying structure of the model. And in this case, the model is just this equation that says price equals 100 plus 50 times the number of rooms.
Okay.
Because that's the line that fits best with the existing data we have.
Right. Okay. So you're saying you have some existing data.
Yeah.
With a bunch of houses with the number of rooms in those houses.
These are the data points.
And the prices of the houses.
Yeah.
You plotted them on this line.
No, you plotted them first, and then you tried to find what is the line that best fits those data points. Yeah.
Right.
So we covered the first thing. That's the model architecture.
Okay.
Features, as I said here, there's only one feature. Feature is basically the input variables, or like the attributes that you consider of individual data points. And here in this simplified example, there's just
number
one feature.
Of rooms
is the feature.
Right.
Yeah.
Sorry, go back to your previous slide. So model architecture is in this case linear regression.
Linear regression, yeah.
Because it's like one line.
Yeah.
Right?
Right.
And features is a number of parameters.
No, parameters is different.
Oh, sorry, my bad.
Features is the input characteristics.
Okay.
So next is parameters, actually. So this model has two parameters. You can see them here. The number 100 and the number 50 are the two parameters of this model.
Okay.
So 100 is called the intercept and 50 is called the coefficient of the first feature.
Okay.
So in generalized way, you will say that like y equals b plus like beta 1 x1 plus beta 2 x2. That's the linear regression formula, where for every as you add more features, you'll get more parameters.
Right.
Each feature will have its own coefficient.
So the parameters scales with the features.
Yes.
Is it a 1-to-1 ratio? Like a
in the case of linear regression, yes, it is 1-to-1, but no, often it's exponential. And then when we talk about GPT-3, remember GPT-3 has 175 billion parameters. This model has 2 parameters. So I want to build up some of the intuition here.
Okay. Yeah, actually, I've heard this before. GPT-4 has 1 trillion parameters. GPT-3 has 107. So I want to know, how do I think, like, okay, 1 billion and trillion is a cool number. Like, I understand, like, oh, something big is happening.
Yeah.
But how do I think about this? Are you saying that every time I'm talking to GPT-4 versus GPT-3, when I ask GPT-4 a question and when it answers me, it looks at 1 trillion things every time.
175 billion. Yeah.
GPT-3 looks at
just start with this example first. Every time you interact with this model, you give it a home. By giving it a home, that means you just input the number of rooms. And you ask it for the answer.
Right.
It's calculating 2 parameters and giving you the answer.
Right.
It's saying it's doing.
But in this case, my input is scaling with the number of features, right? Like in the case of GPT, the input is a simple prompt.
Oh, yes, but actually internally there could be a lot of things. So for example, the features don't have to correspond to the inputs. I could create a feature called the square root of the number of rooms.
Got it.
Yeah.
Okay,
and if suppose I have 2 features like number of rooms and square footage, using those I could create like many more features. I can say the product of the square footage and number of rooms is another feature.
Right.
The square of the number of rooms times the cube of the square footage. So I could create like, 100 features with just those 2 inputs, and that would have 100 parameters. So that's often there's a balance. Like as you increase the number of parameters, you can get more predictive power. But you have to find the optimal number of parameters. Sometimes if you have too many parameters, you might overfit the data. You might just be having too much like computational expenditure that's unnecessary.
Okay. Let's not get ahead of ourselves. I think I have a good understanding of.
Keep in mind that this model has 2 parameters.
Yeah.
GPT-3 has 175 billion parameters.
Right.
And along the way, when we get to neural networks, I'll show you another model that has like about maybe 100,000 parameters.
Right.
And that'll be a good in between.
Right.
For the
Okay.
2.
That makes sense. I think that it also helps me put in context when I hear stuff like, oh, GPT-4 has 1 trillion parameters.
Yeah. So think of parameter as like the number of knobs that can be turned. Like what are the different things that the model can tweak in the training process? Because all that's happening in like model training is actually that's the next topic we're going to cover is model training. So we talked about parameters. Now next we have to talk about the objective function. The objective function is, so we start with just these data points. There's no line here. We don't know what the line is. The line is just what we came up with as a result of training with a given objective function. Right. So in this case, objective function is just what you're telling the AI system to optimize for.
I see what you mean. So the objective function we're using in this case is the price of the home. Another objective function.
It's not the price. Sorry, price is the output like that you want. The objective function is, suppose I give you like a line that looks like this, okay, and a line that looks like this. How do you evaluate which of those 2 lines is better at predicting the price?
Well, I mean, the line comes afterwards, right? Like first you plot houses with their number of rooms and the prices.
That's given to you. You have a data set of 10, or let's say you have a data set of 1,000 homes, and you know how many rooms each home has and what the price of each home is. You plotted them on this.
I'm going to draw a bunch of lines and see where most of the homes fit, like which line most of the homes will fit in, and that will be the line that I will
okay.
use.
So actually, just expand that further. What exactly does that mean? Yeah, you draw a bunch of lines. How do you evaluate if one line is better than the other line?
The line in which most of the data points will fit in, like, or coincide.
What do you mean by fit in? Like they'll be exactly on the line
or close to the line?
Okay. What if I have you have a line that fit? Say there are like 1,000 data points. You have a line that fits like maybe like. All right, sorry, it's hard to think. Let's think about just 10 data points.
I feel like somehow calculus will get involved here. Like you have to find the closeness of the data points to your line and figure that out for every line, and then finally it'll like be some value which will show you.
Actually, that's exactly it. Yeah. So it's not how many fit on the line, because there could be some that are just far away. You're trying to minimize the distance.
Right, which is why I said maybe calculus will get involved somewhere over here, because now I'm going back to my high school days.
Yeah, absolutely.
Yeah.
So in this case, we use an objective function called mean squared error. Basically, error is basically the distance between an actual home price and the predicted line. Price. Right, what's on the line. That is called the error. So here, error could be like $50. Here, actually, this error would be minus 50. This error could be plus 50. That's maybe plus 10. So actually, the reason we square it is because if you sum up all the errors, the plus and minuses will cancel themselves out, but that's still a bad line. So what they do is they take a mean squared error. So for each line, you compute the objective function is the mean squared error. So you look at all the errors for each individual data point, you take the square of those, and then you average them out. That's the objective function. And then that's what you can use to, if you draw like 1,000 lines, to figure out which is the best line. So, and then the last step is the training algorithm, which is actually generating this line or this model for you. And actually, the way you phrased it initially is a pretty good way to think about it, which is randomly generate like 1,000 lines and evaluate them on the objective function to choose the best one. But there's a more sophisticated way of doing that, because this process would take like too long if you just generated like thousands of lines. One of the coolest innovations in machine learning is this training algorithm called gradient descent. What it does is, first it plots a random line. It just assigns random values to the parameters. And then it looks at this is where the calculus comes in. It looks at the slope of that with respect to the objective function and tries to figure out which direction to go in. So it's like, do I go, instead of generating...
Oh, I see. Let me finish your thought and see if I'm headed in the right direction. Monica and I do this. If you find it annoying, then we'll like, because I interrupt her a lot and she's okay with it. So what you're saying is, instead of drawing 1,000 lines and figuring out the line which most closely aligns with your objective function, you draw one line and you move that one line in the direction of what will ultimately be your objective function.
You first draw one line and then you figure out which direction you need to move in, and you keep moving it in that. You shift the here you have only two parameters to play with, so the model is going to play with this. Suppose we call it B and A. It's going to play with B and A, but it knows which direction to move it in to get to a better objective function value. So yeah, it just keeps doing that until...
I'm trying to see why this is needed, because like right now I have an example of like a very simple model. And I'm like, why do you need to go through all that? You just see where the line will be obvious to you, but the line will not be obvious to you when you have an insanely big model.
So actually, even the moment when you have like 3 or 4 parameters, it's already too complex. You can only visualize one parameter.
Yeah, like I don't even know how to visualize.
If there are 2 parameters, if there are 2 features, that's a plane. It's not a line anymore. It's a 3D.
It's a 3D space, and after that, I don't. I've seen a lot of videos in like people trying to explain how to think about 4th, 5th dimensions. Whenever I see those videos, I'm like, yeah, that's cool, but like the next day I forget. Like I don't know. Like my mind can't process more than 4 dimensions. So I see what you mean.
So, and then with machine learning, you get into multi-million dimensions. So this is just a simplified example to understand the concept, but I think the coolest thing is that we have this algorithm that can tell you how to set your parameters such that you'll get to the best objective function value. It'll start with something completely random, and it'll automatically adjust itself until it gets to the optimal value. So that's the cool thing about machine learning. So yeah, I mean, we could go into the details.
I think I have a good understanding of what you mean by models.
It's pretty technical. Yeah. So I that's pretty much like what classical machine learning is like, and there are many different types of like regression is one. There are different tasks you can do. Regression is like trying to predict the price. Classification is another popular task. Classification is like I have two classes and I'm trying to predict like orange and not orange, or like spam and not spam, but it's the same general idea.
So that one's classification and this one's
regression,
where it's not a yes and no, but it's it's a value that you're trying to predict.
The classification has discrete outcomes. Regression has continuous outcomes.
Right.
So it's like, there's continuous, any real number, right? Between 1 and some millions.
So, but the ultimate objective of a model is to predict something.
Yes, either
depending on the nature of the thing that is being predicted.
Yeah,
you have different
types of models,
and the two popular ones are regression models
and classification.
Models.
Those are not models. There's like tasks. Right. They're the two common types of and then there's generation, but that's a new thing. We'll talk about that later. But yes, so you can even think about. We talked about ads, right? So maybe before we get into neural networks, let's think about how this can become even more sophisticated. So what are you trying to do in ads personalization? I am trying to predict for you, for a given ad, are you going to buy this product or not?
Right.
Or maybe that's too complex, buy or not buy. Let's say, are you going to click on this ad or not?
Right. There's something called predictive CTR. Like
exactly.
Click-through rate. Yeah.
Predicted click-through rate. So what I'm doing is, it's exactly similar to this. No, I don't have a slide on that, but I have a training data set that has a bunch of clicks, and I have a bunch of characteristics of users. So I'm like, there's a large data set, and I know the label. In this case, the label is like the price. In that case, the label would be click or not click. It's a classification problem. And then I have a bunch of input features, like maybe there's profile information, like person's
demographic
information, behavioral, mostly it's behavioral information, like about what activity they did in the past. And so I mean,
I can already think of like there would be so many parameters that one could gather.
Yes, exactly. Those are already huge. They have several parameters, and what you're trying to do is figure out optimize those parameters to get to a prediction of whether you're going to click on it or not, to optimize for that that objective function. So most actually tasks that are used in businesses today are just based on like what I would say is classical ML. Has nothing to do with like generative AI or any of the new stuff. So like ad predictions, like recommender systems is trying to recommend, which is very similar to the ads use case.
No, I mean, I spent the last 7 years of my professional career selling exactly that, like an algorithm which can help you predict if you should be participating in this auction or not, because like most of Google media is sold on auction, and like if how valuable is the user and whatnot. So so that's classical ML, like the stuff that I've been selling, or like the technology that I primarily deal with.
Well, it possibly uses neural networks, which we'll get into next. It probably does, or it's not clear. Sometimes they do, sometimes they don't. Maybe with classical ML, it's already good enough. It depends.
Right. Okay, so let's go beyond classical ML.
Okay, so let's go to neural networks then. That's the next thing here. So the concept of a neural network, it's inspired by the human brain. Where the brain consists of a bunch of neurons that are either activated or not. And each neuron... So we have a bunch of neurons that are interconnected. And neurons activate in regular patterns. Like when you see an image of... or when you have like a happy moment. Say when you see your daughter, right? And you're happy, you have some emotion. That activates a certain set of neurons. And there's a pattern to that. And that activation then has a certain output, which is like you feeling happy. So basically the idea is, can we construct an artificial system that's somewhat similar to that, with a bunch of interconnected neurons, and try to figure out patterns of activation that map to certain types of input? It's very abstract, but I can actually go into an example.
Help me understand it this way. Like, I really like the way you, the reason we went into machine learning is because you explained to me the challenge with the classical approach to programming. It's like, when you do rule-based programming, after a while, you hit a wall, which is why you needed to find new and novel approaches. And the new and novel approach was machine learning. Now, like, is it similar to that? Like, did we hit a wall with classical ML that for which we needed to
The wall you hit is, firstly, you need to handcraft these features. Like, you need to know what are the exact features I need, like number of rooms or square footage or whatever. That's one. But I would say the main wall you hit is it can't work with unstructured data. Like, this is, so there's a distinction between structured and unstructured data.
Right.
Structured data is like this. It's the kind of thing you would put inside a SQL database.
Right, like a spreadsheet or something.
Or a spreadsheet. You have rows and columns, and this is very structured data.
Named rows and columns.
Exactly. What is unstructured data? Unstructured data is like a paragraph of text. Unstructured data is an image.
Right.
That's completely unstructured.
Right.
So the classical ML is not good at dealing with unstructured data. I can't feed it an image. I don't even know, like, what am I doing with this image? Like, if you... So actually, the one example I want to talk through for neural networks is image recognition. Right. So there's this very famous like task. It's called handwriting digit recognition. There's a database called MNIST. I don't even know what it stands for, but basically it's a bunch of images of handwritten digits from 0 to 9. People handwrite, like you write 7, 8, whatever. And the task there is to figure out from the image what number is represented.
Okay.
So think about that task. I'm just giving you, it's like...
Dude, I don't even know where to start.
How would you even... what is the feature here? How do you extract a feature? So this stuff doesn't work with in that context.
Like, I've thought about this before, and I was like, I don't even know how to think about this. Like, first of all, how do you even get the machine to see that handwritten thing? Like, I'm like lost there already. Like, what is it? See, let me explain to you what I mean. When you, let's say my baby girl, Isha, she's 6 months old, right?
Yeah.
I'm going to show her an 8.
Yeah.
She does not know what an 8 is. For her, it's just an abstract squiggly line. But at least she can see that in a white piece of paper, there is a contrast and she can determine that there's a squiggly line in the shape of an 8. I'm saying, how do you even show the machine? Because the machine only reads zeros and ones. First, you have to tell the machine that within the zeros and ones, there is like a white paper in which there is a squiggly line in this pattern. Like, that itself seems so challenging.
So that's actually a great question. I think that's a really good segue. You can't do that with this, but you can do it with neural networks, and I can explain to you exactly how we'll do it.
That'd be amazing, because do you understand my question? Like,
I have the answer to your exact question next. Okay, so this is abstractly what a neural network is. And this will become more clear with this example of the handwriting recognition that we're going to talk about. But there's an input layer, and then these are the things that are called neurons. Each neuron is like a neuron in your brain. We don't actually know if this is how the brain works at all. It's just a theory, a hypothesis. But what happens is each neuron either gets activated or not. And then that signal passes through to the next layer. And finally, there's an output layer that gives you the answer you want. This probably doesn't make sense now. Let's go through the example, and then we can see how it makes sense. So the input layer, it receives the inputs. The output layer is like the final layer that creates like the response, and the hidden layer is what's doing the manipulations in between. Like, it's doing the...
What example are we following here? It's that given an input of a handwritten digit from anywhere between 0 and 9.
0 to 9,
The goal of this model is to predict
which digit that is. Exactly. So in that case, actually, let's think about what is the input layer to that. Okay, what am I going to input from the image? Like, do you have any ideas?
No, I mean, that's my question. Like, how do you break down an image to a machine? Am I wrong in thinking that a machine can only see zeros and ones?
Sure.
Like, a machine literally can only see a high voltage or a low voltage, which is then represented in 0 and 1.
So let's take a simplifying example. Let's say these images are all black and white, okay? Or let's say they're grayscale. That's like simpler than
let's do black and white.
So grayscale. And in this particular data set in MNIST, they're 28 pixels by 28 pixels.
Okay.
And 28 multiplied by 28 is 784. So there's 784 pixels.
Okay.
Each pixel is an input. And the value of each pixel is between 0 to 1. 1 is if it's totally black, 0 is if it's totally white, and in between is how gray it is. That's how grayscale images are encoded.
Oh, I see. Okay. So if it's an 8, you'll take like a square pixelized image.
28 by 28.
Right.
Yeah. You sequence it into 784
and
pixels.
all the places where it's actually 8, let's say it'll be 1. And all the places where it's just white paper, it'll be 0.
Yeah. Or that's if it's black and white, that's what it is. If it's grayscale, it's more sophisticated. You have an entire scale between 0 and 1. How 1 is most black, 0 is most white.
For simplicity's sake, let's take black and white. It's like a squiggly line, but it's like a...
Yeah, then it's zeros and ones, exactly.
Pen to paper is 1.
Yeah.
Only paper is 0. Let's simplify it.
Exactly.
Okay.
Yeah.
Okay.
Yeah, that's a simplified example. Realistically, it would be grayscale because there are some places where it's like maybe and it's easy to generalize this to a color image, like because color you break it down into RGB values and you say 784 pixels times 3. For each pixel, I'll give you an R, G, and B value.
Right.
That's how you would convert it. Yeah.
Oh, that's another cool computer thing that you can break down. I mean, well, computers adopted it from the primary colors, but I see what you mean.
Yeah, you can compose.
You can create any color from RGB, basically.
Exactly.
Yeah.
So in this case, let's just simplify it and say it's only grayscale, or you can think about it's only black and white. 784 pixels, that's the input layer. What you want out of the output layer is finally a number, right? 1 to 9. Right. But realistically, what happens is your output layer has 9 neurons. Each of them are numbered 0 to 9. And the output is a prediction of between probability of how likely is it that this image is a 8. So suppose you feed it a 7,
got it.
And
if it's my handwriting, is
because ideally, sometimes there will be it won't always be 100% certain. So
like a 4 may look like a 9 depending on how you do it.
Yeah,
got it. Okay.
So the goal is that when you feed in a 7, all the pixels go in,
right?
And the layer corresponding to the 7 is the one that lights up the most,
right?
Okay. So let me show you an example of what this looks like.
Cool.
This neural network. So the input layer is, as I said, 784 input neurons. Okay, that's how big the input layer is, because we said 28 by 28, and that's each pixel. And you can think of these greens as the activations. The blank ones are not activated. In this case, actually, there's shades of green because it's grayscale. And then this output layer for this 7, it's activating this 7, which means that it correctly recognized that it is 7. And then there are these 2 things in between called hidden layers. That's where the manipulation is happening. That's where the weights and parameters are coming in.
That's the magic. That's the secret sauce.
Exactly. That's where the magic is happening. So it's just like the case earlier we talked about with a linear regression. First, you start with some random way of activating things, and then you evaluate the loss, and then you look at how do I optimize this. So actually, let's go back to this list here and think about what all these things here correspond to. Maybe you can start with features. That's an easy one to start with. In this case, features there are 784 features, each pixel value. That's it.
Right.
Where in the home prices case, remember, we had square footage.
Feature.
Or we had only one feature.
Right.
In this case, we have 784 features that we're putting in. Model architecture, it's a little complex, but it's what I showed you in that diagram.
Instead of linear regression, it's neural networks.
It's a neural network.
Okay.
Yeah. Parameters. Okay. Before we talk about parameters, let's talk about the objective function. The objective function, again, as always, is to minimize the loss. So just as, remember, in the regression case, we talked about...
You start with one random line and then you move it towards...
Yeah, but what is the objective function? We're measuring what is the distance between that line and the actual
data
houses.
plot.
Yeah. So in this case, what we do is, once we create a model, we put all our data through it, and we measure the distance between the predictions and the actual values. That's always what a objective function is. You want to minimize the distance between your predicted values and the actual values.
Right.
So the predicted values, for the data set you fed it, it may be like 0, 1, 2, whatever. Actual values may be something completely different. And you come up with a way to measure the distance between those two. That's the objective function that you're trying to minimize.
Right.
And then
so I see what you mean. So you're saying that in this case, in this model, you'll start with like, let's say 100 examples
Yeah.
of like
That's
papers.
the training data.
Yeah, the training data would be a bunch of places, papers, 28 by 28 pixels, where you've written a bunch of numbers. And obviously you know what the number is, so you're training the data. So you'll start with your 784 input data. You obviously know what the answer is. So probability will be 1, right? But what's happening in like what actually happens during the training?
Let's talk about that. So let's talk about what's happening in these hidden layers. So there's a thing called an activation function here, which is there are lines connecting every node to every other node in the next layer. Okay. In this architecture, we're just assuming I have 2 hidden layers. Each of them has 16 neurons in this example. It's just arbitrary. We can't really get into like why there are 16.
Right.
Arbitrarily, we assume there are 2 layers and 16. This is describing what's happening at the first layer. For each connection between a neuron in this layer and a neuron in this layer, it has a weight. Right. Okay, so these all have activations that are A1 through AN, and then they all have weights. So suppose here I want to compute the activation here. Why is this green? Why is that lighting up as opposed to not lighting up? So what I'm doing is I compute the activation function of that neuron. This neuron is connected to 784 input neurons. And through this function here is just a random set of weights and biases. I determine whether this should be activated or not. And it's going to give me like a 1 or a 0. Or it could be anything between a 0 and a 1. So it's going to output an activation. And then the same thing is happening at the next layer again, but much smaller because I have only 16 now. And the same thing is happening at the final layer. So there are only 16 things here.
So does it progressively reduce the hidden layer? So like the first one's 16, the next one's what?
In this case, they're both 16, but it progressively does reduce.
Yeah, it reduces. Okay. Yeah. And then eventually it'll come to
the idea of what we think is going on here, we really don't know, is that each layer is developing some abstraction over the first layer is literally looking at individual pixels. The next layer we think is learning some patterns behind those pixels. Like, oh, does it have a straight line? Does it have a loop? Something like this. And then each subsequent layer is a higher level of abstraction until you get to the final layer that tells you what number it actually is.
Right. Okay.
That's what's happening in this. So now I just want us to think about how many parameters there are here. So each neuron is connected to each other neuron in the next layer. 784 connected to 16 neurons here. And each one also has a bias. Bias just means, like in this case, like this parameter that's not a coefficient of any feature. We just call that the bias.
Right. Like 100 in this case is the bias.
100 in this case. So in this case, like each neuron has its own bias and n weights.
So are you saying that so the hidden layers right now, for simplicity's sake, there are only 2 hidden layers, but it could be any number of hidden layers? You're saying the first one, when you start training the data, you just start with something random?
Yes. Okay, first let's think about what all the parameters are. Let's go here and see. There are going to be 784 times 16. This is the number of parameters for these connections.
Right.
16 times 16 is the number of parameters for these connections. And 16 times 10 is the number of parameters there. And there are this many biases because each neuron has its own bias. So there are 13,000 parameters in... Sorry, I'm getting sun in my eye. There are 13,000 parameters in this model. So remember we talked about with linear regression, all that's happening is first you initialize a random set of parameters and then you move towards the right direction to get the right parameters that are minimizing your loss function. Loss function is just the inverse of objective function here, that are optimizing your objective function. And the way this happens, it's a combination of something called backpropagation and gradient descent, which we talked about earlier. So when there's an error here, like, suppose it recognized the ones as zeros instead, based on the error that we find from the objective function's value, it knows like how to propagate backwards and adjust the weights to get to the right direction to optimize the objective function. So that's all that's happening. It's just like linear regression on like a hyper-dimensional scale. You're just tweaking the parameters like in an intelligent, non-random way. You could theoretically, like, remember originally you said like we can draw 1,000 lines for regression and find which is the best. Theoretically, you could do this. If you had infinite computational power, you could just generate like infinite combinations of these 13,000 parameters and just say select the best one. That itself would be like a way to do it. But since we don't have infinite computational power, we want to optimize. We want to test only the relevant combination. So every time we know which direction to go in based on this gradient descent thing, and it moves in that direction and only tweaks the parameters in one way until it gets to the optimal set of parameters that can most accurately predict the digits.
So what I understand from this is the breakthrough over here with neural nets. So like I'm gonna like summarize our story. Our story is classical programming hits a wall. Then you have classical ML, hits a wall. Then the breakthrough is neural nets. What's the breakthrough with classical ML? The breakthrough is instead of you programming the rules, the algorithm figures out the rules. What is the breakthrough here? Is it the hidden layers and this back propagation thing?
The breakthrough is that you don't need to figure out how to structure the data. Like, remember in the classical ML, I have to structure the data and say, this is the feature. Like, the feature is like the number of rooms or the number of houses. Here, you don't have to structure the data. I just give it 784 pixels.
I see what you mean. Yeah, you're just giving it raw pixels.
Exactly. Or in the case of language models, which we'll talk about next, it's raw text that you will give it. So I don't have to structure the data at all. And I don't have to structure the features. Like, because again, in classical ML, typically, there's a lot of handcrafting of features that you have to do. In a regression model, sometimes you will find that like linear regression may just be the wrong example. Linear regression means there's a straight line relationship between the two variables you're trying to plot, but maybe there isn't. Maybe it's a polynomial like equation. So it takes a lot of time to customize and find the right one that fits your data. In this case, you have to do none of that. It's just an abstract structure that can apply to like many different types of data sets.
It also sounds to me like every next evolution, we're making it simpler in some sense. Obviously, we're taking advantage of the massive computational power, but
can we get another beer?
So like, let me explain how I mean it. So in the first case, we had to do the one-on-one, like we had to create the rules, right? Now in classical ML, you don't have to create the rule.
Can we get the hazy?
In the classical ML, you don't have to get the rules. So like from the programmer's point of view, it's simplifying your job, right? Like you don't have to do the rules. But you still have to like figure out the features and whatnot.
But there are some trade-offs that come here because one thing that goes down is interpretability. Like I don't like in this model now, if you tell me that, look, based on this input, I got this output, and you tell me like why, I can't give you the answer. I'll say there are some 13,000 parameters in there. I don't know what they're doing. They gave me this answer.
That's another thing. You have answered one of my questions, because a lot of times I've heard people say like the black box nature of things, and we don't really understand why it's doing.
This is where the black box comes in. Because in the case of the linear regression, it was very easy. If you give me, I know exactly what parameter corresponds to which feature, because the parameter is the coefficient of a feature. And if you give me a new house, and my model predicts that your new house has a low value, and you ask me, hey, why does my house have a low value? I can tell you exactly why it has a low value. I'll say, hey, my model multiplies your number of rooms by 50. Your number of rooms is low. So like your house price is low.
That's a really good example. That's why like if like one of the concerns that people have is like increasingly with algorithms making a lot of our decisions, which is happening, right? Like increasingly, it's going to make a decision which might seem unfair to us, and there is nothing we can do about it, and no one will be able to explain why that happened. It's like why we're like one of the examples I can think of is like, imagine you apply for something and if your application is denied. I'm generalizing it, like some application and it's denied.
A credit card application is a good one.
And imagine like your application is denied, but you are not given an explanation why that happens.
Because no one knows the explanation. Like once you get into these, once you increase the like 2 parameters 10 parameters, yes, it's okay. I can
Right.
explain to you what's happening. Once you get to 13,000 parameters, it's like no one understands
Right.
what these parameters are doing.
Right.
And there's some effort going on right now into ML explainability, but it's hard. There's a trade-off between models that are more powerful
Yeah.
versus models that are more explainable. And that's just
Right.
like
I think,
a challenge.
that's okay. I understand. So with every new breakthrough, you're getting more powerful models, but obviously there's a trade-off here, and the trade-off is you're losing a view into
Explainability.
what's actually
Yeah.
happening.
Because like this thing here is a complete black box. Like no human being can look at this and understand. Like
Yeah, it's a scary picture.
yeah, like mathematically maybe you can understand some of the equations, but literally you're just saying like there's a bunch of random. Usually this is treated as a vector in because you don't say these are 784 individual values. You treat it as one vector with 784 dimensions or
Right.
one. Yeah, and it's all these multiplications that are happening. Usually they're like matrix multiplications because you would treat them all together. So. And that's actually a reason why GPUs are optimized for this task.
Actually, that's what I want to understand as well. Like, what NVIDIA, if you have, like, I don't know if you follow stock prices or not, but like, if one of the interesting stocks that you could have followed over the last 5-10 years is the NVIDIA stock. It's insane how much it's increased. And I think one of the analogies that people give is like, they've observed that whenever a gold rush is happening, the people that tend to make a lot of money are the people who supply coal miners with their equipment.
Yeah, and picks and shovels.
Yeah. And in this case, like if you extend this analogy to like AI, like if there's a gold rush happening, then NVIDIA is getting enriched. I understand all that. Like, I don't fully understand, like, what is it? NVIDIA used to make graphic cards. What happened suddenly?
So graphic cards are actually a type of processor that's optimized for a very narrow function. Whereas it's a GPU versus CPU.
Yeah.
CPU is a general purpose computing machine. GPU is optimized for a very specific function, like of rendering graphics, which actually turns out is ultimately matrix algebra. And training of neural networks is all matrix algebra, because at the end of the day, you're doing like millions of matrix multiplications. That's what's going on here. Every time you compute an activation function, every time you have to do that for each and every layer, like, there are 13,000 parameters. So it's just a bunch of matrix multiplications. And a CPU can do that, but it's not optimized for that. So whereas if you take a narrow machine, like a GPU that's just optimized for doing one type of operation, it can scale, do it more cheaply, do it more efficiently.
Okay, that makes sense. Okay.
With the rise of neural networks that made these matrix multiplications like really important, and that's like most of your compute resources are spent doing matrix multiplication, it made sense that we're going to build specialized hardware, GPUs, and then Google built TPUs.
Yeah, tensor processing
units. Those are also optimized for matrix multiplication. And I think they're actually even further optimized if you use Google's TensorFlow library for doing the
I want to get into that. Not now, whenever you think it's appropriate, but I want to understand, like, what is TensorFlow? We
can talk about that. TensorFlow is just a Python library. TensorFlow and PyTorch are the two common libraries that make it easy to do exactly. Like, imagine if you want to write a program that creates a neural network.
Yeah.
Like, you don't want to have to like sit and.
I only bother about this and this. Like, I don't want to be bothered with this. So TensorFlow does all the hidden layers.
And PyTorch, yes.
They do the hidden layers.
They do everything. They create all the... You can define how many layers you want. It's just an abstraction layer on top of this neural network. Like, and it does the training algorithm. Like, you don't have to code how to do gradient descent, how to do backpropagation. They have that built in. So that's ultimately... They're just like high-level Python libraries that make it easy for you to interact with these low-level concepts.
That makes sense.
Yeah. Okay. And Facebook built PyTorch, Google built TensorFlow. They're both pretty popular. I don't know how things will change now with like LLMs and stuff. We have to see what happens. But so that's
so the big breakthrough first with the classical ML. Sorry if I repeat too much. It's just for my own sake of understanding.
Yeah.
With classical MLs is you don't have to write rules.
Mm-hmm.
With neural nets is you don't even have to give the features or structure the data.
Exactly.
So we're giving, and that way it's becoming more powerful.
It's automated.
And it's also like
powerful.
in some sense like less work even. It sounds like, hey, you don't have to write rules. Hey, you don't have to give features. Just give me the raw pixels and I'll do all that for you.
Yeah.
Obviously, it requires a lot more computational power, as can be seen with scary looking math, scary looking graphs.
Yeah.
And you're losing explainability.
Yeah, exactly.
But so I understand. So neural nets can do stuff like this
and deep
prediction.
Learning, if you hear the deep learning term, it just refers to a neural network where you have more than one hidden layer. That's all deep learning means. It means the network is deep.
So deep learning is a type of neural network.
Yes, exactly.
Okay. So if you go back to the circle view, there's AI, there's classical and ML. And then within ML, there's neural nets, and deep learning is type of that, where it's more than one hidden layer.
Yeah, exactly.
Okay.
Yeah.
So now we're down to deep learning, which is like more hidden layers. And now we can do more complex things like image recognition.
Yeah.
This is just a basic example like handwriting.
And we can also do text. Like that. Yeah. So that's the next thing. So we wanted to talk about generative AI, right?
Yeah. But before we go to generative AI, so right now we have an example of like a text recognition, handwritten. But does the same logic apply to image recognition? It's like, here's a picture of a man sitting in a backyard in summer afternoon wearing shades in front of a mic. Like, how does the algorithm know all that? Like, how does it... is that part of generative
text?
No, like an image. Like someone took a picture of us right now.
Yeah.
Like, Midjourney now has this described...
that's a combination of text and images, because it's trained on like text that's captions for the images.
Right.
Yeah.
Okay, yes. You're saying first it has to deal with captions.
Yeah.
And then the advanced thing is to be able to
relate the images to the text. So we can next move into like how text is dealt with.
Okay.
So first question is, how do you encode text, right? Like in this, the first question we had about images was, how do you encode an image?
Right.
And then we said, we look at each individual pixels.
Yeah.
And each pixel is encoded in RGB value if it's color, or like 0 to 1 if it's grayscale. Now, how do you encode text? So this is actually very complicated. There's two main steps to encoding text.
Wait, that's not hard, no? Like encoding of text is something that computer scientists have, like ASCII and like binary. All that is encoding of text, no?
Sorry. I mean to say like encoding it in a way that can preserve some semantic relationships.
Oh, I see what you mean. How do you infer meaning from
Yes, exactly.
Because so far it's only been manipulation of bits.
Yeah, you can arbitrarily come up with some encoding that doesn't but the key is, can I come up with a way of encoding text that preserves semantic relationships, the meaning of words.
Right.
And I think one of the key breakthroughs there is called embeddings. It's basically word vectors. It's a method of turning a word into a vector, like how we take an image here and turn it into a 784 length vector. Similarly, you can take a word and turn it into a vector. And you can do it in a way such that it preserves the semantic meaning and relationship.
Give me an example if you can. Or...
Yeah, so that's actually in the next slide. So for this is called word embeddings, okay? Right. So for each word is turned into a vector like this. In this case, these are the dimensions of the vector. There are like 7 dimensions, but in the case of an actual model like GPT-3, I wrote down how many...
Oh, it looks very similar to like a concept that Google has and maybe others have as...
The embedding dimension in GPT-3 is over 12,000. So this thing, the 7 that you have here, there are like 12,000 dimensions.
Yeah, like just by seeing your first example, it says cat, and it says a cat is a living being. It's a feline, human. Oh, well, it's not those things, but like you have these groups. So like internally at Google, we have this thing called a knowledge graph. I don't know if it's internal, but like we have a concept of knowledge graph where like on Google search, a lot of times you will see a knowledge panel when you search for something. So let's say if you search for Barack Obama, there'll be a special result where it'll be pictures of Barack Obama and it'll say American president. Like it has all these things. So for example, the way to do that is by having a knowledge graph where it knows that this person is an American president. Like there is a knowledge graph. So every entity has a graph with many connections.
Okay.
Right? So it sounds like a similar concept.
I think they could be related. I don't know much about knowledge graph, but it's possible that they are related concepts.
Yeah.
Basically, what's happening here is where for each word, you're figuring out like what other words and what context does it appear in.
Right.
That's what an embedding is.
Okay.
And you can set a number of dimensions for an embedding. In this case, there are only 7 dimensions, and they're all like very interpretable, which is unrealistic. In reality, there are going to be thousands of dimensions, and you can't really interpret them. But the key point is like, what you're doing is figuring out this word, what context does it appear most frequently in? And that's what an embedding is. It's saying in these contexts, it appears more frequently. So you go through your entire corpus of training data and figure out in which context the word appears more versus less.
So yeah, in this case also, you could just give it a lot of unstructured data and then it can figure this out. Meaning you give it all the text that's ever been written on Reddit, which is a lot.
Even more. Like GPT-3 was trained on 3 billion or some number of billion tokens. I think.
I don't know what tokens is, but I see what you mean. Meaning you can keep it super unstructured and it'll create an embedding out of whatever data you give it. Which is, and will that happen for every single word within that training data?
Yes, absolutely. So GPT-3 has the vocabulary size of GPT-3 is 50,000 words. And the embedding dimension is about 12,000. So in fact, that leads to it having 6...
Wait, that means every word has 12,000 columns, and its relation, like how frequently does it come with those 12,000? That's insane. So what is that?
50,000 multiplied by 12,000 is about 600 million. That's the number of parameters.
Yeah.
But that's only like the beginning. Remember, it has billions of parameters. So every number here is a parameter of the model.
Yeah.
The model can then find what is the right value for this parameter. So right here, there are going to be, as we said, 600 million plus parameters with GPT-3. But before talking about parameters, let's think about what is the value of creating these word vectors. As I said, they preserve the semantic relationships between words and concepts. So to give you an example, look at this graph here. This is a visualization of these word vectors for man, woman, king, and queen. And what you can do is you can do vector algebra. Probably you learned this in high school, like vector algebra is you can add and subtract vectors from each other. And one cool example is if you take these vectors, you do king minus man plus woman, the result it gives you is the vector for queen. You do father minus man plus woman.
You're saying like there's an independent field of study in mathematics, vector algebra, and like the researchers realized that if you were to create these embedding,
you could convert words to vectors. You can use the
algebra that they have figured out over here, and this pattern seems to repeat a lot in science in general, right? Like there'll be some independent field of study somewhere, and then there'll be like some emerging tech somewhere, and then they realize, oh, we could like use all this stuff from this other field of study. Sounds like that's what happens here.
I think one of the earliest times this happened was with Descartes in the 16th century when they got really stuck with geometry and they realized that geometry and algebra could be related. This happened with what's called Cartesian math. Descartes in like the 16th century realized that there are a lot of problems you're having in geometry that can't be solved. But once you map geometry onto algebra, like you say, the geometry is just like algebra on like a graph. You can solve a lot of like geometric problems that you previously couldn't solve by converting them to algebraic problems, because there are a lot of results in algebra that directly you could apply to geometry.
Yeah, I mean, I'm sure you would appreciate that because you studied logic, but like that's what sort of the genesis of Boolean logic, right? Some guy was independently creating Boolean logic for, I think his pursuit was to like prove the existence of God. George Boole. No, I don't know.
It could be. I don't remember.
Some interesting story. Maybe I'm butchering it, but like his pursuit was to like prove God or something, and he was like trying to find out, oh, I'm going to take all these statements from Bible and then I'm going to apply some logic and then drive conclusion. And I think he discovered Boolean logic. And then over here, these people who are dabbling with computer science are like, oh, we could use this existing field of study and look what we've made. So it looks like something similar is happening here.
Absolutely. And I think ultimately all of it is just mathematics. Like there are a lot of results in mathematics, like a lot of relationships that people, it's about encoding different objects into a mathematical formulation and then being able to like leverage those results and relationships. And that's exactly what's happening here. We know how vectors are related to each other. Once we convert words to vectors, then we can leverage those.
This is very cool. Like
those relationships.
You're saying that if you were to do all this, then you'll come up with vectors of man, woman, king, and queen. And if you apply that vector logic, like the way you
preserves these relationships.
Yeah, you
between
could
them. Yeah,
like because that's how we think about it. It's like, okay, man, woman minus that, then that's a king. Well, that's cool. Okay,
absolutely. So then, this is the first part of how this is the encoding problem. We talked about how to encode our input into features, right? That can go into the model. For images, it was the pixel values. For words now, you start with first tokens. A token is like an individual word. Think about it that way. Like cat, kitten, these are tokens.
Yeah.
That's step one.
Is that a common parlance in the...
Yes, in this. So in fact, if you go to GPT 3 or ChatGPT, it'll always describe its limits in terms of the number of tokens. So the context size is one of the important limiting factors of GPT. With GPT-4, I think the context size is
25,000. Huh?
No, it's 4,000 or 8,000 tokens. And then there's an expanded version that's like 32,000 tokens, but that hasn't been released yet, which means that the total of the input and the output that it can generate at max, it can have 4,000 tokens.
Why don't they use words like words? Like, what's wrong with words?
Yeah,
what's the difference between words and tokens?
That's a good question. I don't know the exact answer. I think there's a difference. Like, for example, the word man and the word men are the same, two different words, but they're the same token.
Oh, I see what you mean.
Yeah.
Oh, okay.
So like man, or if you have like man, man's, man apostrophe s, like plurals and all that. So those are like concatenated into the same token.
Right. Okay.
Because ultimately, whether it's man or like man's, they're
but actually, why are they treated the same way in the model? Because they have different semantic meaning, no? Different semantic meaning, but they have different usages.
That's true. Actually, I don't know the exact. I could look it up, but I don't know the exact relationship between words and tokens. I know that it's not a one-to-one relationship. There are some things that are bundled together, like different words into the same token.
Okay.
And sometimes the same word is multiple tokens based on if a word has two meanings. Like then those are separate tokens.
Okay.
So yeah, we were talking about.
So actually, if we backtrack a little, I want to go stick to our story. Classical ML goes to classical approach to programming, then classical ML, then neural nets, then deep learning, and now we're moving to like generative stuff.
This is still deep learning. Yeah, but this is now a basis for like generative
to analyze text and how to encode text.
Yeah.
So vector algebra came to the rescue.
And you can put it in this same thing here. Again, you can put all those vectors here and you can run it through this. And you could run like a classification model like this, where instead of like 0 through 9, suppose you have your spam problem. You can have two classes, 0 and 1, spam, not spam. You can put those inputs here, all those vectors. It's a little more complicated because you're just putting the individual vectors there. You need a way to get the sequence and order and things like that. So the architecture becomes a lot more complicated. But the basic concept is the same.
Right.
You have a way to encode text. You can now feed that into your machine learning models, and you can use it to perform tasks like classification, prediction.
Right. Okay.
So that's how you encode text, and that's how that fits into like deep learning.
Right.
Yeah.
Okay.
Yeah, and then like, so I want to go back to this thing here. So we talked about like features, right? And now let's think about what are some of the other things that are going on for a language model.
Actually, we didn't even come to language model. How do we get to language model? So what is a language model?
Yeah. I guess now if you... So
this is a model.
Yeah, exactly. So then let's talk about like what is generative AI, right? Like, generative AI is just types of models that create new data that mimic characteristics of like the training data. So it's like instead of doing a prediction task, the goal is generate something new that's similar to what was in the training data. Images or text. The most popular use cases are images and text. There's also audio and video, which are like more complex, and I think they're a little harder to understand.
Yeah, but if it's actually it's mind-boggling. Like with Mid-Journey, it's able to like imagine new image. I mean, you need a prompt, obviously, but it's crazy. Like the output is so aesthetically pleasing, and it never existed before. It's like something that our minds imagine. Like, how the hell does it do that?
Yeah, that honestly, even I don't understand. It's a combination of images and text. I mean, through using the concepts that we discussed. But yeah, I don't exactly understand how Mid-Journey specifically works. It's a combination of the image.
Yeah, but like just general idea of like, forget Mid-Journey, but even GPT-4, for example, the output it has, it's not so. For example, I'll go back to my first example where I was asking, it's like, oh, my baby girl, I want to start solid foods. Its answer, it's not as if it's copy pasting that answer from like the billions of training data that is found somewhere. Like, oh, I found this Reddit thread that someone was asking the same thing, so I'm going to copy paste. It actually uses the context in which I've presented the question and then answers accordingly. So it's like, it's like us, like this conversation. If you take all the words, it's a novel thing. It's never happened before. That's what we do, right? How is this machine able to do that? I don't like. That's the magic for me.
So yeah, I don't know if I'll be able to answer exactly that. I hope like we have some building blocks that we've built up so far, and we can talk about specifically how ChatGPT is trained.
Right.
There are a couple of more concepts that we can cover there, and then we can discuss.
Yeah. So this is model. I think I have like based on what you explain, I'm getting a good understanding of this. Then what is a language model? What is a large language? Because I keep hearing this word LLMs everywhere. I don't know what that means.
A language model, we talk about generative models. Generative models' goal is to generate something new that resembles the training data. Language model, the goal is just to generate text that resembles text that was found in the training data. So the very basic function of a language model is to predict the next word given a set of words. So if I give it a string of like, some 10 words, it'll predict what is the most likely next word to come out of it based on what it learned from its training data. That's at a very base what a language model does. And you can extend that to instead of predicting the next word, I can say predict the next 100 words or predict that's the token size. That's what we were talking about with
given
GPT.
A word.
You can say anything given so when you go to ChatGPT, you can type in just one word if you want and press enter and it'll generate something.
That seems ineffective, no? Like it should be given like you're saying it could work even with a word.
Yeah.
But obviously the more input, the better. Like
the more input you
predictive
give it, the
power
better.
It'll have.
But all it's doing is like if you say sorry, I had one example here. If you have a word like I don't remember. Like this is a blank, okay? Then it'll look at all the past instances in the training data where this combination of words existed. This is a followed by what was the next word there, and look at what is the most probabilistic outcome of that next word based on my training data.
Okay.
That's the first thing it does. And then if you ask it what's the next word, again, it'll say, now the context is this. I've put it into my context. What's the most likely next word to come out of it? So what it's doing is trying to predict the next word based on its training data. And this is the way the training data is encoded in the model. And the architecture of GPT-3 is extremely complicated. I have like this slide on it. I cannot explain it to you. Unfortunately, it is too complicated. But I think the key thing I want to emphasize is there are multiple loops and layers of like feed forward network. This thing that says feed forward network, what that is this thing. This is called a feed forward network.
Right.
This is the most simple kind of like neural network where everything is just going in this direction. There are way more complex neural networks. They're called like recurrent neural networks or long short-term memory networks that have more complex architectures. But what is happening here is there are a bunch of different neural networks that are combined together. They're probably like, like n number of different layers of neural networks here.
Right. So you're saying that like if you go back to that one neural network slide where you have like the 784 pixels predicting, So with GPT, the level of complexity is so high that it has many of such neural networks.
It has n number
and the
of
hidden
such.
layers between them is also insanely large.
Yes. And that's how you get to 175 billion parameters, because as I said, the starting point for the number of parameters is here, and that's actually 617 million, because we discussed that there are 50,000 vocabulary words, and then there are about 12,000 embedding dimensions.
Right.
So that itself is 617 million parameters. And then that's going through and getting multiplied by, remember how when we talked about here, each layer was getting multiplied several times. So similarly, how this 784 led to 13,000. So in GPT, we're starting with 617 million instead of 784.
So help me understand this, just because it's like mind-boggling the amount of computation that is going through this. So every time I'm asking a question to ChatGPT, like it must be doing an insane amount of computation to answer.
Yeah, so we need to separate two parts
that
of
only so
machine learning. There's training and inference.
That's what I was going to come to.
Yeah.
Is the computation only required for training, and once you have trained the model, then the answers are not very computationally intensive?
No, again, like going back to this example here, the training is the process of finding the parameters.
Right.
It finds that 150 are the right parameters. That's what training is. And in the case of this neural network, training or learning is finding the right weights and biases. That's finding the right value for all these 13,000 parameters. That's training. Inference is given a new training example or a new example, calculate all these 13,000 parameters and output the final value. That's a much simpler computation.
Right, but in all of these previous examples, the final value was limited, right?
Mm-hmm.
It was either like a concrete, discrete, yes, orange, yes, no, apple.
Yeah.
Or it was like a set of values in the home value price, which could be like between 1 and infinity, but it's still like a arithmetic, right?
Yeah.
But in case of generative AI, it's it's still like a permutation of combination of words, but it's
remember, it's multi-step. At every stage, it's just predicting what is the next most likely word. At every step is just one prediction that's coming out.
So you're saying it's actually as simple as that? It's just predicting the next. So
that's what a language model does. You give it some input text, it takes this text and it says what is the next most likely word to come out of that. First, it does that. Then now that word that it output,
it's always a word. Like literally, it's just
a token. Yeah. Then that word becomes part of the context. And then it says, now given this entire context, what's the next most likely word?
To this day, the way ChatGPT or ChatGPT-4 is working, it's like at the algorithm level, it's only predicting the next word every time.
Yes, it's only predicting the next word every time. Yeah. That's the basic language model. There's some like reinforcement learning on top of that too. Input human preferences and stuff for like the style of response it gives you. But yes, at every stage, it is just predicting the next word. Given a context, what is the most likely next word to come out? That's the prediction task, and that's what the
it doesn't even consider, okay, here's the next 4 or 5 words, because a lot of times your next word is not just influenced by the previous words or the context, but you might choose what your next word should be based on what the other following words could be as well, right?
Yeah, that's how a human would do it, but that's not how
maybe that's the next
GPT
evolution.
Yeah, I don't know exactly how that would happen, but right now a language model just predicts the next word. And there are a couple of steps in this that I wanted to talk about. So how ChatGPT, so this actually talks about how GPT-3...
Move the mic a little bit closer. Yeah.
This is GPT-3, how it's trained. The output of this...
Actually, before we jump into all this, what does GPT stand for? Is that
it's Generative Pre-trained Transformer. Okay. Or it might be generalized pre-trained transformer, but I think it's generative. But the transformer is this type of architecture. It's the model architecture, like how we had linear regression, and then there was feed-forward neural networks. Transformer refers to this type of architecture. Generative just means like it's generating text. Pre-trained refers to the fact that it is trained and it has these parameter values already fixed.
Okay. And is that something that OpenAI came up with, or like GPT is like a general term, like everyone can have their
No,
own?
they just came up with their own name.
So when I hear
It's
the
just a
word
type of
GPT in the
language
wild,
model.
it's always to do with the OpenAI's GPT. Like it's not that Google will have its own GPT and
Yeah,
Facebook
that's
will
right.
have its own.
No, they'll have different names.
Different names.
And that's
Okay.
actually an interesting question, because recently OpenAI has been trying to enforce their trademark on GPT, because a lot of people have been publishing applications with the name GPT in it. And OpenAI wants to avoid this name becoming genericized.
Right.
So
too bad. Cat's out of the bag.
yeah, I mean, I think there are some legal methods they can use. There's this, I don't know, trademark law is very complicated. There's this thing where if people are using this word in a generic way, then you can't enforce that trademark anymore. So I think Xerox was one example. People started using Xerox in a generic way. It's like, I'll Xerox this
Yeah,
paper.
Airbnb is another one.
Yeah. So in those cases, you lose your trademark ability.
Yeah.
So I read recently that
there are pros and cons. Because it's nice to be in a position where your company's name has turned into a verb. Like I'll Airbnb it, I'll Google it, I'll GP it maybe.
But
yeah,
I think
I'm
they
sure there are
don't want to
concerns as
be
well.
associated. Like if I make an application called Chaos GPT that does like
or like
bad shit,
porn GPT.
yeah, exactly.
Yeah, you don't want to be
they
associated.
don't want to be associated with that. So
yeah.
But okay, let's just finish this thing. So this is GPT-3. ChatGPT is one step beyond GPT-3. So this thing here is initial language model. That is like GPT-3. Okay,
Right.
It's what it starts with, and then it does this thing called reinforcement learning based on human feedback, and it comes up with a reward model. What that is not just predicting the next word, but like it's taking human preferences into account. So the humans evaluate a bunch of samples of prompts and responses, and there are a bunch of like, basically they hired like contractors to evaluate like prompts and responses, rate is this a satisfactory response or not. And that's the second step on top of the language model. All it does is predicts the next word based on the training data and the model. It just predicts the next word and then the next word, and then it produces a string of text. This process, it's called RLHF, reinforcement learning with human feedback. That's like the next innovation on top of language models, where they input human preferences into the style of response the GPT gives you. So it's not just about predicting what is the most likely next word, but you have to predict the most likely next word that is like liked as an output by human beings generally. So you can't give output that's...
Help me understand this. So GPT-3, it doesn't have that human feedback.
No.
But is it gibberish that it produces, or is
no.
Is it like too rude and you need human feedback to like make it more polite? Like
yeah, it's like either too rude or it's like not super context aware. Like it's just not the style. Yeah, actually, I don't have a good example of like what kind of response it
but
gives
it's not
you.
gibberish.
No, it's not gibberish at all.
GPT-3 could very well work as ChatGPT. You might not like it, but it's gonna be legible.
It's not conversational. It's not intended to be, because the way GPT-3 is trained is like you gave a snippet of text. It's like that text was in the middle of an article, and then it's predicting like the next text from that. That's not conversational. So this process just makes it conversational. That's all.
Right. Okay.
GPT-3 is like normal text. What it can predict the flow of text,
right?
But it's not optimized for conversational text.
Right. So the innovation with ChatGPT was using GPT, which is a language model, and make it more conversational, which is what I'm enjoying.
Yes, exactly. Okay. In fact, it's not, the model itself is called Instruct GPT, which is supposed to be like taking instructions and fulfilling those instructions. So yeah, but ChatGPT is based on that basically.
Okay.
Yeah. So basically, that's everything I wanted to cover on language models and AI. I think I just have one or two more slides that talk about now what this means now, how you can use GPT to like build applications and do cool things. But
I'm like very interested about. So like obviously I've seen ChatGPT. I'm paying the $20 subscription. Honestly, I feel like $20 is too little for the value that you get out of it. I mean, we're grateful to be thinking
Yeah.
like this, that $20, like we were blessed to be in a situation where $20 seems like nothing, but you know what I mean. I mean,
Yeah.
like it's good value for money. Like you have a person you can talk to who's like a very smart person who has a great general knowledge about everything. But what are and the other thing I want to like talk about is like just the pace at which everything's going on. It seems like it's insane the progress that AI has made just over the last 1 year. And
Yeah.
a lot of people keep saying that it's exponential. And like it's hard for humans to process exponential, but what does that mean for our future? How better, like, are we heading into like just all the technologies exist already where you can think of a world where anything you see on the screen of your phone or your laptop, you can be sure if it's generated by an algorithm or if it's real. Like
That's
I can
true.
already see a path to that world.
Yeah.
Like absolutely indistinguishable. Like you, let's say, see a video by a person saying something. There's no way for you to tell if this is real or not. Well, I mean, it's not even far fetched. Like I think in a year or 2 years we'll have that time with
Yeah.
the
I
hyper
agree.
realistic images that you're seeing. That's like that's one area. But like, what are some other possibilities with this technology?
Okay, I have one request. Do you mind if we like take a moment to just look at these last two
Yeah, let's do
concepts
that.
that I have on exactly how GPT is being used in applications? Just understand that for a minute, and then let's pause and come back to
Yeah, for sure. Let's do that.
what are the larger implications of it. So right now, we got up to ChatGPT. What this thing can do is have a conversation with you. You ask it a question, it answers it, and that's all it can do. And it's only doing that based on its training data. It doesn't have access to like anything else. Like, so ChatGPT was trained on something like 300 billion tokens from the internet.
It's 300 billion words.
Yeah. I mean, but the tokens, it's not deduplicated. Like if the word "the" appeared like 100 times, that's 100 tokens.
Okay.
Yeah.
What has it been trained on? Like everything on the internet?
Yeah. I mean,
like
so
everything, every post that's been written on Reddit, every movie review on IMDb.
So OpenAI does not reveal this, and this is part of the criticism of OpenAI is that they're not very open in revealing. Like, yeah,
That's such an irony, you know?
Yeah,
In
exactly.
that sentence
So
itself,
this
OpenAI
stuff
is not
that we're
very
talking
open.
about, like, no one knows if this is how ChatGPT was trained. This is the best guess of like researchers.
Oh, really? It's all close.
Yeah.
Why are they called OpenAI? I'm curious. Do you know, like, what does the open stand for? I thought it was like an open source project first.
Yeah,
It's not, right?
100% not open source.
It's a for-profit company.
It has a complicated structure. It started as a non-profit. It actually got a lot of investment from Elon Musk and a bunch of other people. So it was a non-profit first, and then they transitioned to a capped profit company.
What does that mean?
A capped profit means that like they set a limit, a cap on how much profit the investors can make. It's something like 10x or 100x. I forget. I think it's 100x. I don't remember, but that means if I invest $1 million, at most I can get back 100 million. If there are more profits beyond that, that goes back into the company.
Oh, okay.
So
Interesting.
non-profit just means.
Are there other companies that follow that model? That popular companies that you know of?
No, I don't know of any. This is the first one that I know of. So yeah, they created this new structure called capped profit because they realized that like the funding they were getting through being a non-profit was not sufficient for like the training that they had to do and everything. And then they became capped profit. And then yeah, Microsoft then invested heavily in them. And Microsoft now, I think, owns 49% of OpenAI, and the other 51% is from the original entity.
Right.
So it's a weird, complicated.
So you're saying no one knows what it's been trained on? It could very well be everything that's ever been produced on the internet.
There is actually evidence that OpenAI itself doesn't know what it was trained on, because in some papers they released, like, they used words like, oh, this thing was inadvertently included in the training data. And like people were like, what does inadvertently mean here? So no, I think they mostly know it, but they don't release it. It's also unclear what the legal and ethical boundaries are of what they trained it on. That's extremely unclear. right now, for example, a lot of companies are trying to lock down access to their data recently. So Reddit was a huge source of training data for OpenAI, and recently Reddit locked that down, and they said now it's against our terms of service for you to use Reddit data to train your machine learning models. And instead now they're offering a paid service where they say, oh, you can use our data to train your machine learning models, but you have to pay us.
But what's done
for
is
it.
done. Now that GPT-3 has been, like, you can't remove. Actually, that's another question I have. Can you, once you have trained the algorithm, and let's say there's some legal complications, say that, hey, you need to ignore all of this understanding, will it like update its vector map?
No, I think realistically what would happen is if that happened, they would just say, sorry, this model is illegal. Now go train a new model that's legal.
Right. Okay.
Yeah. So,
but in this Reddit situation, they can't do that with GPT-3, even though it's been trained on.
It's
or
kind
they
of
won't
a gray area. Like, I don't know. Like, legally, it is a gray area because it's publicly available, this text that's on Reddit. Like, anyone on the internet can access Reddit.
Right.
Wikipedia. Stack Overflow is a big one.
Yeah.
So all these were used as sources for training data, and then those people feel like they're not, both like Stack Overflow and Reddit, and also the users behind those websites. Like, it's kind of unfortunate that like their work is now being monetized. Being monetized in a way that they're not getting anything out of it.
I imagine this is going to increasingly become a huge problem. Like with Midjourney, for example, I'm sure Midjourney has also done something similar, like trained on. Like, I think the underlying technology that powers this is Stable Diffusion, which is trained on like 1 billion images.
And it's not clear what the copyright status is also of those images, right?
You can, like, Midjourney, you can say the photography in the style of some famous, like, Lebowitz, right? Something, and it'll do that. That person's not going to get any money. Like celebrity images can be generated, and like celebrity voices, whatnot, like.
Yeah, I read recently there was an artist called Grimes. I don't even know who this person is. They said that, oh, if you want to generate AI-based music in my voice, go 50%. For it. And let's share 50-50 or... So I don't know what the...
Anyways, I don't want to...
let's finish this thing and then we'll come back to this. So the thing I was going to say is, okay...
Oh, cool. What is this?
Here's an example of how... Okay, sorry. Before we get to this, let's talk about what is the limitation here. Right now, what can I do with this? This model was trained on some 300 billion tokens of text. The cutoff was sometime in 2020 or 2021, I think.
Oh, yeah, because sometimes when I ask you a question, it says that I don't know anything after.
Yes, exactly.
Which is unfortunate. A lot of questions I have is like with more recent stuff.
Oh, yeah. So that's exactly what we're going to look at. So like now all this does is it created a language model based on the training data that it had up to 2021. But now what if I want to do stuff with it with more data that I have? Like, how do I do that? And now everyone is, that's currently one of the hottest opportunities right now.
Actually, building. So ChatGPT does not know how popular it's got in some sense.
No, it doesn't.
That's so funny, no?
It has no idea. It doesn't even know what ChatGPT is.
Yeah, exactly. Yeah. That's another interesting thing.
Yeah. So, but I think one of the biggest opportunities right now, what everyone is trying to figure out is how do I connect ChatGPT to some text that's more interesting to me than what it was trained on.
Right.
And it could be like my own company. I have my internal database at my company and I want to answer questions based on that. Or like maybe you have your own...
Like health data. It's like,
your health data.
Look at my Fitbit log. Everything. Unstructured data. Because I have my Fitbit log for the last 5 years. And like suggest some things that I could improve. That maybe Fitbit cannot.
So let's try to think of a simpler example, because Fitbit logs is not typically what I would call text data. That's like very structured data. But think about if I had like a database in my company. Actually, one example I saw recently was a guy that built a ChatGPT based app that would look at the history of all Lex Fridman podcast transcripts and answer any questions based on that.
Oh, that's a good one.
Yeah.
That guy has like really like academic people on his
podcast. Yeah, exactly. So, but he has like hundreds of episodes. Each episode probably has like tens of thousands of words in its transcript. How would you even build a system like that could interact with that level of text and find the right... Because remember, ChatGPT has a context window, limited. It's like 4,000 tokens. So I can only put 4,000 tokens of text into ChatGPT.
Actually, could you not because I don't know much about this, maybe it's a stupid question, but take the ChatGPT model, retrain it again with additional data, and that additional data would be the Lex Friedman transcripts. Is it not possible for any normal person to retrain these things?
It is possible, but that retraining actually doesn't give it new knowledge. That retraining would mostly just give it new ways of answering questions, a new style. The way to give it knowledge is to connect it to an external database. Retraining would be like a prohibitively expensive process every time. So yeah, suppose it does even give it new knowledge, retraining. It's ridiculous to say that I need to train a 175 billion parameter model over and over again every time I wanted to have some new knowledge. So that's not going to scale. The way to do it is you connect GPT with external knowledge databases. And that's actually one of the recent evolutions that's happened and that I want to talk about. This is a graphic from one of my colleagues, actually. His name is Vikash. He works at my company, and he's been writing a lot about like AI and LLMs, and he created this graphic of how you would create a question answering system. So think about this, like you have a question about some private document that you have, okay? Right. So what's happening there first, like let's look at this box. You have what's called a vector database. Right. We talked about like words to vectors,
embeddings.
Right? Embeddings.
Yeah.
That's exactly what's going on here. First, what you do is you create a vector storage of your documents. In this case, assume documents.
Yeah, I've been hearing a lot about these new databases that specialize in vector storage, like Pinecone. Have you heard of Pinecone?
Yes. So Pinecone is probably the most, it says here, example
okay.
Pinecone. Yeah.
Okay.
So Pinecone is probably the most popular vector database right now. There are a couple of others.
Oh, so I see. So these are specialized database instead of like relational, like row-wise storing.
Yeah.
They do embedding.
Exactly. Oh, okay. And we talked about embeddings, the
so
word
they're like
vectors,
the NVIDIAs
right?
of the databases.
Well, NVIDIA is processing, not storage.
Are any of them public? I want to buy the stock, maybe.
Pinecone recently announced, Andreessen Horowitz invested $1 billion or something in them.
Good for them.
It was huge.
Anyways, go on. So this box.
So first, what you do is you take your entire knowledge base, all your documents. In this case, it could be your personal notes or your company's database, and you convert them to embeddings. OpenAI has an embeddings API, and you upload them all to a vector database. Okay, so that's the external knowledge base that you have now.
Right.
And when you
so sorry, I keep interrupting you, but I just want to clarify. So the advantage of doing this is you've translated into a language that these models can understand, which are embeddings. So the language that these new models understand are embeddings.
Yes.
Okay.
And also, embeddings can have mathematical operations on them to understand similarity.
Yeah.
And also the storage is more optimized.
Okay. It's because it's designed to store embeddings.
Yeah. Okay. Exactly. So when you ask a question like blah, 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 whatever, like suppose this is the Lex Friedman example, right? Yeah. Suppose these documents are all Lex Friedman podcast transcripts. Suppose your question is like, hey, what did Lex say to David Deutsch or something about physics? Right. So then the question gets converted to an embedding.
Right.
And then you go and query the vector database, and you find you do a vector similarity search for what are all the documents that are similar to this query. So you can do vector similarity search because like vectors are mathematical objects, and you can look at what is the distance between any two vectors. So you can say, given this vector, give me the 10 vectors that are closest to it, that are most similar to it. So given this question, I can ask for the 10 vectors that are most similar to this
Basically,
question.
It sounds like with this whole vector logic, you've like with Boolean, the advantage was that you've started to doing arithmetic on like language. Like that's what it sounds like with vector you're able to do. You're able to like manipulate language without actually knowing what is in, like understanding the meaning.
It's the same thing.
But you're able to like abstractly manipulate it and then come up with like
And originally we were talking about words as vectors. Now we have documents as vectors.
Oh, okay.
So now it will retrieve the 5 documents that are most similar to your question. So you ask it a question, you say, tell me what Lex said to David Deutsch about like physics, some random thing. It'll look for what are the 5 documents that are most similar to it. That's what it creates as the context. And then it passes that context to the LLM, like ChatGPT. And now the question that ChatGPT just gets is like, given these 5 documents and this question, answer the question. That's something you could directly paste into ChatGPT right now.
Right.
But the thing is, if you connect it to an external knowledge base, you cannot give it the entire transcripts would be like, like thousands of pages, and that can't go into ChatGPT.
Right.
So what's happening is those thousands of pages are being stored as a vector database, and you can efficiently retrieve whatever is most relevant to your question.
Why wouldn't ChatGPT just build something that makes this whole process easy? Like
they do. It's called ChatGPT plugins.
Oh, okay.
Yeah.
What are those? Like
it's exactly this. Basically, anyone. So I can build a plugin to ChatGPT.
I don't have to like do all this vector business. Meaning, like,
no, you have to as the plugin developer if you want some. So the user doesn't have to.
Yeah, let's say I'm the lay user.
Yeah,
I'm the layperson, and I want to connect ChatGPT to like my own private database.
Yeah, where is your private data?
Forget database, because database itself is something technical.
Yeah,
like I have I don't know, like my grandfather has a bunch of like has a diary that he's been writing in for the last 50 years, let's say.
Yeah,
and it's in digital format.
Yeah,
it's in a Word doc.
Yeah,
I don't want it to be released anywhere.
Yeah,
but I want like ChatGPT's smarts to be able to tell me stuff from that diary.
Yeah,
like,
so
how can I do this as a layperson who doesn't understand vector business? Like, I don't want to use the word vector. How can I achieve that?
Yeah, you can't, but the app developer, so if the diaries are stored as Microsoft Word documents, Microsoft can release an ChatGPT based application that does this for you, and it says, hey, all you got to do is like click this button to connect your Microsoft Office account to ChatGPT, and you can ask any questions of it. So the first step is the app developers are going to do this. So Microsoft, Google, Slack, Discord, WhatsApp, all these applications that have data in them, that have documents, that have knowledge bases, they all have to think about what is their business strategy, what do they want to build, and they're probably going to build these applications, and you as an end user can then connect depending on where your data is. If your data is in Google Docs, then you can probably connect to Google and whatever application Google built. We talked about Notion. Notion has its own AI. So yeah, it depends on where your data is. And this is still territory that's extremely unclear what the business strategy will be for these companies, how they will develop. But if you're an independent app developer, you can do this. So this applies not for users. This is for app developers. If you want to develop an app that users can use. So you make this podcast, right? Docents. Suppose you want your users to be able to interact with this Docents podcast through a natural language interface. You could make this app. You could upload your whole transcripts to a vector database and make an application such that users can say, hey, tell me what did Nikhil say on Docents podcast about vector databases, and they could get the answer. So yeah, this stuff is what app developers can do using GPT. Okay.
And this thing is an architecture for ChatGPT plugin.
Yes, for ChatGPT plugin, or more generally for a language model to interact with an external database.
Right. So again, if I step back and then like go with our high level story.
Yeah.
Like in the evolution of AI, from classical we went to from classical programming we went to classical machine learning, and then from there we went to neural nets, and at every point we were hitting some walls. We're finding solutions. What? We'll share this, and then we're hitting a wall, and then we're finding new solutions, and it led us to generative AI, which is what has fascinated us, which is the reason why we're here. And ChatGPT is the start, but this is another innovation that's come on top of it, which is adding plugins and giving that language model an external source of knowledge.
Yes, exactly. Because ChatGPT doesn't have any knowledge other than what it was trained with.
Right. What are some other such innovations that are happening on?
Okay, so I want to talk about one last thing, which is like this is just giving it external knowledge.
Yeah.
There's also giving it whole other external capabilities and tools. Like, for example, ChatGPT is a language model, but it's not good at math. It's not good at like programming. If you ask it what is 5,033 times 3,044, probably won't give you a good answer to that. It's just not
because it's the next word prediction type thing.
Yeah, exactly. But ChatGPT doesn't need to answer that question. All ChatGPT needs to know is that, hey, this looks like a math problem, and to answer this question, I'm going to use a calculator. That's what it needs to do. And then all it needs to do is figure out what are the two numbers that I need to plug into the calculator, plug them into the calculator,
Right.
and get the result for you. So that's
Actually, I have a question there. You said that ChatGPT, the only thing is doing, even though at our level, it looks like it's a fascinating thinking person, like in reality, the only thing it's doing is just predicting the next word.
Yeah.
Right? That's all it is doing.
Yeah.
Like in reality.
Yeah.
Then how is it going to do all this that you describe? Even that, it looks like it's a math problem. Like that is like, seems like it's more abstract thinking. It's not just predicting the next
That's where language model meets prompt engineering. That's where you have to develop the right prompt to get the right response. So the right prompt here could be like, hey, what tool do you need to answer this question? Imagine if you just put that prompt, then...
No, but from how you said it, you made it sound like ChatGPT is going to figure all that out for you. So you just say, what is 18,000 times 1,544? And ChatGPT will figure out, okay, this sounds like it's a math question.
Yeah.
It sounds like in this math question, to solve this math question, I have to invoke a calculator.
Yeah.
So this sounds like thinking.
Oh, yeah, but
it's not predicting next word.
Sure, but I'm saying this is a program that you have built where ChatGPT is the central part of the program. And you, the
I see what you mean. You're saying you're still thinking from an application developer's point of view.
Exactly. Yeah. ChatGPT is not doing this on its own.
And ChatGPT will never be able to do all like thinking on its own.
I'm not sure why that's relevant.
Like never, but you know what I mean.
But I am like OpenAI could easily release a new thing called Agent GPT that does this. So I'm not sure why it's relevant whether ChatGPT can do this or not.
Right.
Like,
I see what you mean. Right.
Most likely that's what's going to happen. OpenAI is probably going to release something called Agent GPT or some version of that is an actual agent that can do things, that calls ChatGPT and asks it specific questions. So I would ask ChatGPT given a task.
That's a good conversation to have because how would Agent GPT work? Like, do you have any insights?
That's the last example that I have here. It's called...
It sounds like the next evolution, right? Like
yes.
So our story has sort of like, our discussion has sort of been leading into like this breakthroughs and getting more powers.
Yeah.
Right? Like it sounds like with plugins it gets more power, but like agency, like when you say agency, you mean a sense of agency. That's like... Right now, it's from my point of view, from a layperson's point of view, like the only thing differentiating a human from a machine is like a sense of agency. Like there's like we're not just in a meat body, right? Like we have a sense of agency. There's like a soul that we have in our meat body, like, and then we do things in the world. Like whereas a machine, even though let's say someone creates like in 10 years from now, like using whatever new breakthroughs in biology or whatnot, like a biological machine with like ChatGPT, like some Westworld kind of thing, like it won't have a soul like we do and have a sense of agency. But the way you're...
I don't know if those two things are related, like having a soul and agency. I could give a program simple agency. I could just say like, if I give a program access to my email account and say, hey, you can write emails, that's agency, but that's not a soul. Like, it's just simple forms of agency.
Yeah.
Like, suppose I create a ChatGPT that connects to my Gmail. I say, hey, every time you get an email from Piyush, like, just take that text, maybe look up some knowledge base I have and write a response and reply to Piyush. That would be an agent.
Maybe I'm using the word agency wrongly, but just the way you were describing the thought process earlier, like, oh, looks like this is a math problem.
Yeah.
Maybe I should take like 2 numbers from it and you should use a calculator. Like,
but I can extend that to the same example. I can say, look, if I get an email from Piyush and he has a question, figure out how to answer that question and answer that question, use the tools you need.
Yeah, but you're saying all this very matter-of-factly. Like, this is scary and amazing stuff. Like, at the same time, like, you're, I don't know, maybe because you're in this world, you're a product manager working on AI. But from my perspective, this is scary stuff, man. Like, I don't know. I don't understand how matter-of-factly you're saying it. It's like, this is thinking. Like, you're thinking.
I think so. The level of scariness depends on like the level of empowerment you give it, right? So if I'm saying I give it access to my emails and I give it access to write emails for me,
that's where the agency comes in. Like, how do you know you'll stick to like that's the agency? I mean, like, like the way you describe it, it sounds like it's like, oh, because it sounds like you're generalizing that agency when you say that, okay, I'm going to give it a math problem and it's going to start thinking. It sounds like it's a math problem.
Yeah.
And I need to do this.
Yeah.
Then you're again going into like the rule-based world. The rule is you can have agency as long as it's a math problem. But someone's going to come and say, okay, well, let's remove rules out of it.
Well, but I'm saying you define what are the things you connect it to, right? Like
what are the tools it has?
Yeah, exactly. What are the tools it's connected to? So that's how this system. Actually, let me go to the next slide, which is the last one, which is exactly about this. This is a system called Jarvis, developed by Microsoft in collaboration with...
props to the branding team, whoever came up with him.
Collaboration with Hugging Face, which is the biggest like open source library of like machine learning models. It's called Hugging GPT. What it does is it uses a centralized language model agent to find... to take your question or task and to break it down into like what are the right tools that I need to use to find to do those tasks, and then it does those tasks. So here, let's take a look at this.
Hugging GPT?
Hugging GPT, because it's called Hugging Face is the company. It's an open source like
that's a nice
project that just has a repository of like models, and this is Hugging GPT. So task is, can you describe what this picture depicts and count how many objects are in the picture? Okay, that's the task that comes in. Then first thing is the language model does this like task planning. It figures out like what do I need to do to achieve this task. And then the second thing is it translates that into model selection. So Hugging Face is a library of like machine learning models. They have a model for pose detection. They have a model for like image recognition. They have a bunch of different like ML models, and they might even have a model or a calculator tool. Instead of models, you can think of it as tool selection. It might have a calculator tool in there. So it goes and selects like what is the right tool I need for which.
Where does it select the tool from? From the Hugging Face?
In this case, we've just connected it to this set of tools. Like Hugging Face has a list of set of tools, but abstractly, you could connect it to whatever tools you want. But you would always control what tools you give it access to.
Right.
And if you give it access to Gmail, you could control, do I want to give it access to read my Gmails or also write Gmails?
Right.
And if you give it write access, that gives it a lot more power. So what it's doing is it's finding like a set of different tools. It's breaking down the task into, it says in this case, what this picture depicts and count how many objects. So first it's breaking down, it's like, I can describe it as a herd of giraffes and zebras grazing in fields. So for that, it needed a model that translates text to like captions. It figured that out, that's the first thing I need.
Actually, can you, like, based on all that we have discussed so far, can you, like, just based on our discussion, help me understand how that happened? How did it describe text from that image using all the models and the evolution of AI that we have discussed so far?
So first, it took this text that says, what does this picture depict? What this picture depicts? And it figured out what is the out of the tools.
So first, it had to break down the picture into raw pixels, RGB pixels, right?
Let's say it processed the text first before it processed the image.
Yeah.
It processed the text and it said it needs a model that can do image description. That's the first thing that it figured out. Then it went to Hugging GPT and look, it figured out that, look, I need this model called image captioning. That's the model.
Right.
Then what this model does is it takes this image and it breaks down those RGB values and it gives a caption.
Right.
And the caption returned is a herd of giraffes and zebras grazing in fields. But the thing is, these are all specialized models. They're not general models.
Right.
This model, all it does is it takes an image and gives you a caption.
Right.
But here is like the central brain or like the central brain of the system that's doing this coordination, that's figuring out what are the tasks that need to be done, and it's selecting so it's like a manager in a company. Imagine you have a company and like there's
that's exactly what I was thinking. It's a this is high level thinking, high level planning, high level thinking.
Exactly. It doesn't know
complex
how to do
execution.
Like image captioning. It doesn't know how to do like object
But that's what
detection.
managers are supposed to do. Like delegate. Like like it's in some sense like as employees, we're all like APIs. We're all at different level. Like the more higher level you are, like the more complex tasks you can do. Like a CEO at his level will call an API, like his VP is like, hey, like go make this stuff in India for me, like create iPhones in India. That's a very complex task.
So that's actually what this is evolving to now. This is becoming a high level manager, and it's able to break down like the next level tasks that needs to be done. And all you need to do is connect it to the right tools or models that can do that next level breakdown of tasks that it needs to do. And if you connect it to this Hugging Face library that has all of these open source models,
like you're saying it so matter of factly, like this. Like, I think you're too close in this world, and you've been talking to a lot of people who are too close in this world. I'm 100% sure when you speak to most lay people, this is insane. Like, this is going to take away everyone's job. Well, I shouldn't say hyperbolic like everyone, but you know what I mean? Like, this is going to, a lot of jobs
it's very question. Yeah, I don't know if everyone's jobs, but I would say already right now for engineering, I think is software development is pretty heavily hit, where I give it a specification like write a program for me that does XYZ. It can act as like a software developing like tech lead or architect or manager, and then call the models that will develop like what are the sub programs that have to be written, write all those scripts, and it could increase engineering efficiency. I don't know what ratio, 1:2 at least, but could it go to 1:3, 1:5, 1:10?
Yeah, it's like that exponential curve thing, no? Like we think like we humans, like from an evolutionary point of view, we don't think exponentially, but like if you take the progress, which is exponential in this case, it's it's going to increase the order of magnitude in no.
But I think this is the key like innovation now with ChatGPT. What people have found is that it's not the purpose of this type of like language model is not just to do question answering, but to serve as like an orchestrator of like different tools. And given a task, it can do things like break down the task into its subcomponents. And if given a set of tools, it can identify what are the right tools that can do this task for me. And we already have like a huge set of specialized models. Many are open source. Companies may have many closed source models. And this, you can set up an orchestration framework where I can get a task, break it down, go find the right tools to do the task, execute those, rinse and repeat. That's what these tools like Auto GPT and Baby AGI that they're doing right now. That's leading to what people are calling artificial general intelligence, which is this engine that is just like able to like generally do any task that's not like a specific or specialized task.
Yeah, like yeah, it's crazy. Like even in our discussion, we started with a simple house prediction or determining if it's an apple or an orange, and it's come to already like in 2023 where it can figure out and do a lot of tasks. So actually, the other thing I want to talk about, I remember in like when we were talking on phone, you mentioned that you believe that this is the iPhone moment, and that really struck with me. Like, can you help me understand what do you mean when you say the iPhone moment, and why do you believe that this is the iPhone moment?
Oh, yeah. First, I just want to clarify, I didn't invent this terminology. Like, it was the NVIDIA CEO that came up with this terminology. He said we're going through an iPhone moment right now. And so let me say why I think he said that and why I believe in it. So what was revolutionary about 2007, the iPhone moment, was that there was a shift in the fundamental interface we use to interact with businesses and services. Previously, everything was based on like desktop applications or like often non-internet based. It was like, imagine if I had to like book a hotel or like call a taxi. I had to make a phone call or go online on my computer. And with the iPhone, there was a change in the way I interact with the world around me, which is through this device I have in my pocket. I can press a button and it enables completely new use cases. Like, imagine I'm standing on a road and I need a taxi to come to me and pick me up and take me where I need to go. That did not exist before.
That was really magical, right? Like Uber was magical. Like
exactly.
Yeah.
Or like Uber Eats or Swiggy in India, like those kind of things where, I had such a pain, like where in India especially, like explaining to someone on the phone what my address is like
Uber,
huge nightmare.
I think I increased my lifespan because of Uber, and let me explain why I say that. Because one of the back when Uber launched, I was in India and in Bangalore, and Bangalore is infamous for its taxi system to be based on negotiations and not like a fixed price. Every place you need to go, you have to negotiate the price, and it was just the worst thing that I had to engage in every morning. I'd be like, okay, how much for like that building? Because I lived very close to my office, but still not walkable because it was very hot and whatnot. So like, how much to that building? And that guy would be like 100. I'm like, it's literally that building. Like, what? This is insane. He's like, no, that's like whatever. Like, and it was
and it wasn't. You're saying it's just Bangalore. Maybe it started that way, but it was Hyderabad. I lived in Bombay and Hyderabad.
No, Bombay. Like the one good thing about Bombay is like they still like. I mean, even before Uber, they were.
No, actually, I'll tell you. The worst thing about Bombay is in Bangalore, it's a negotiation, right? In Bombay, it's not a negotiation, and they just say yes or no. So if I say I want to go here,
that's a really good point. That's another problem. Like the one problem is the
yeah.
pricing ambiguity, and the
I
other
prefer the negotiation because in Bombay it was like I would go to the guy, he would say no. And instead, just open the conversation with like how much you want.
Yeah.
So
you're
anyway,
right. I think I get your point. Like iPhone, the iPhone moment enable like all these businesses to come out because everyone had access to a technology like which was in the palm of their hand. It had like mapping services and like internet. Like remember that famous thing by Steve Jobs where like the way he
the three things,
the iPhone,
right?
It's an internet communicator device, a music iPod, and then he repeated that. It was like
an iPod, a new phone, and a revolutionary internet communications device. Yeah. That is one of the most amazing product launches in all of history. But the key point is that there was a new interface, a new way in which people were interacting with businesses. So if you were a business, let's say say you're Amazon, okay? Like originally, the way in which people interacted with your business was they logged onto their laptop, they went to Amazon.com, and then they transacted with your business services. Now there's a whole new interface. I have my iPhone, and what it needed for you to do is you need to develop now an iPhone application, a mobile application, so that I can interact with it on my preferred way of interaction. Because now, like, I no longer want to log onto my computer every time I want to order.
Or I don't want to call anyone.
Exactly. Yeah. So I think that's the key shift that happened is there's a new method for consumers to interact with businesses and services.
Right.
So I think when people say there's a new iPhone moment now, what that means is that there's now yet another new way in which consumers want to be able to interact with services. So I want to be able to interact with Amazon, probably not just through the regular Amazon app UI, but I want to have some like natural language interface to interact with Amazon. I want to tell Amazon that, hey, like, based on everything you know about me, based on maybe you and I had an email conversation about like some jeans. We've talked about easy jeans. You actually recommended these easy jeans to me. I'm wearing them. I love them. Like, what if that was somehow captured in a knowledge base and I could just tell my AI that, hey, like, go order the jeans that Piyush told me about. That's how I want to interact with computing systems and with businesses in future. I don't want to have to go to Amazon or to the Uniqlo website and figure out what is I have to go to my email, figure out or remember in my own memory like what you told me and type in the name Easy Jeans and get that. Now it's like I want to have a connected natural language interface where I can say, look, Piyush told me about this thing.
Like you sound like you mean like a life companion of sorts where they're context aware about all the happenings in your life and they can like do stuff for you, like an assistant. Maybe you shouldn't use the word companion. Maybe that's different. But
I think that is going to be the new interface, like because we talked about ChatGPT, we talked about access to knowledge bases.
Right.
That's already coming. We already have so much of our knowledge stored in email. If I combine my Gmail, my WhatsApp conversation history with you, plus if there was some way like my phone calls with you and these interactions could be recorded and stored, like there's just such a wealth of information. And if that is a ready-made context for me to have interactions, then the interactions I'm going to have with businesses are totally different. I'm just going to say, oh, okay, like go order the thing Piyush told me about. And
yeah, are there examples of any such early businesses that you know of that are using this shift in interface as you describe it, or like the paradigm shift from?
So right now, I think what people are trying to do is convert existing interactions into natural language interactions. So that's what ChatGPT plugins does. So ChatGPT recently, or OpenAI about a month ago, released a service called Plugins, where you as a business owner can provide a plugin to ChatGPT. And one of the original plugins they came out with were Kayak, Expedia,
Kayak, the travel
OpenTable.
provider.
Yes,
Oh, okay.
OpenTable, the restaurant bookings, Instacart. Actually, Instacart is something Rukma and I used recently. So we keep our shopping list in Google Keep. We have a shared Google
Yeah,
Keep
we do
where
that as well. Yeah.
we can both add things to
Yeah.
our shopping list.
Yeah.
And then literally we copy pasted that entire shopping list into ChatGPT using the Instacart plugin and said, hey, order all these items. And it automatically generated an
Really?
Instacart order. And in fact, it asked us for some ambiguities. It said, oh, hey, you asked for like oranges. Do you want this type of orange or this type of orange? And then it was like, oh, you wrote yogurt, but like, what is the quantity you wanted?
Yeah.
Blah, blah, blah. And then it got that information and it immediately generated an Instacart order with everything. And then all I had to do is click like approve to buy or like cancel. And over time, that could learn my preferences. Maybe it just already knows that when I write apples, that means I like Fuji apples. That's my favorite kind of apple. When I write yogurt, I mean like whatever, XYZ yogurt. It saves my preferences. And then my interaction with Instacart is extremely simplified now. I don't have to like go and select like these detailed like options. I just write a very simple like Google Keep list. I say I need apples, yogurt, potatoes, onions, whatever, and it knows exactly what I mean by all that. It saves my preferences.
So what I'm hearing you say is that like one of the things that's going to happen is you have the existing way of doing things, and it's going to remove that friction. And it's going to make it more easy to do these things, right? Like make it more natural language. Like it's going to like, so for example, right now you have your shopping list, you go on Instacart, you do all that whole process, that friction is removed, and it'll all be done automatically, and you can sort of rely on that interface to take care of everything. If there's ambiguity, like figure out from your preference what kind of orange you would like and all of that.
I think it still remains to be seen exactly how this will evolve. Like, are my preferences going to be stored in Instacart, or will I have my own personal AI where I store my preferences?
Yeah, I'm not so much bothered about like how it'll be implemented technically. I'm like sort of envisioning what our lives will look like with this, and I can see what our lives will look like. It's gonna.
Have you seen the movie Her?
Yeah, I love that movie, Joaquin Phoenix.
Yeah, I think like it's
actually that. So it's a great segue to my next question. Like movie Her is a great segue. Is okay. This. The way you described it is how existing businesses or existing use cases will transform. But what I'm curious to know from you is what are some new things that will emerge because of the new capabilities of these technologies? Like businesses that weren't possible before, or ideas that weren't not possible to be executed before that now can be executed because of like this powerful technology we have. And then we discussed the evolution of this powerful technology, like AutoGPT being like this manager that you have access to.
Yeah.
Like, hey, do this for me.
Yeah.
Okay. Like I'm anthropomorphizing AutoGPT, but it's going to be like, okay, this is the high level task. Here's how I'm going to plan to do this task. I'm going to break it into subtasks. Here are all the tools I need to achieve these subtasks. And it's like a genie, man.
Yeah. So, I mean, this is like the $1 billion question. If I knew the answer to this, I'd probably go be building this product right now and I wouldn't be
But you're in this industry. Like, do you know of like some ideas that people are building that are use cases that have not been possible before, types of businesses that have not been possible before?
Yeah, to be honest, like I think it's still very early and I cannot think of any such use cases right now that are popular. ChatGPT would be one example. Like
Midjourney is an example.
Midjourney and Chat, but they're like very base level examples.
Yeah.
They're not.
They will enable these businesses.
Maybe. Yeah, they will ideally enable like in future businesses. And I've been trying to think about what are some businesses that would be enabled, but I think there is no clear answer to this right now. If there were, there just can't be at this stage because it's still like early stages. If people knew the answer already, like that would already be there right now.
The other question I had related to the topic that we're discussing right now is, like, we have discussed this previously, like an ideal, like one of the things that we've always talked about is like a life of a solopreneur, right? Like a solopreneur is a person who like has a product or a company, is basically able to fund their life and lifestyle with a business that they are a sole employee of, meaning like they run the business. It's a single employee company, right? And it sounds like these technologies can really enable that vision, right? Because you can make it easier to code. If you're thinking of an online business, you can make it easy to code. Like there are all these no-code applications. You can call all these APIs with Auto GPT. You can almost use it as like a tech lead and whatnot.
Yeah,
that's the one side of thing. The other side is, it sounds like as there's more and more development in these technologies, like these interfaces getting more and more powerful, and like these API calls are getting more powerful. So it sounds like any idea that you have will sort of be short-lived, or you'll always live in this existential crisis, is that some API is going to basically generalize your problem. Like, let me give you an example. Like one of the things that I've been experimenting with Midjourney, because I find all this stuff very fascinating, is, have you heard of this thing called Dream Booth?
No.
So Midjourney is an application where you can basically create any image that you can imagine, and you can imagine that with a prompt. You write the prompt and it'll imagine. But let's say you wanted to imagine yourself in different situations, like Nikhil as in a spacesuit, or Nikhil, like, I don't know, wearing whatever, like a 17th century costume. Midjourney cannot do that because it's not trained on your specific face era. So Google came up with this research, and then like an open source product called Dream Booth, where you train the stable diffusion model on your selfies, or like
there was this thing called Deep Dream earlier, right?
Yeah, maybe there are other products similarly, but the idea is that you create your own version, right? So there are a lot of businesses that are coming up with this. Like a lot of, I think you were the one who actually showed me. You shared this this guy's Twitter stream about this business he created where he was
headshots,
right. I was actually very inspired by that. Like this whole thing, my wheels started turning. I was thinking about solopreneurship, because that guy
AI
is basically
generated headshots,
a solopreneur, right? Like what he's doing is basically he's taking people's selfies and then he's creating a AI generated headshot, which is an amazing business. All of us are on Zoom. We want like a nice professional. It costs like $500. That guy is doing for $30, and like it's like MP3 versus Wave, right? MP3 gets you 95% of the quality, and no one cares about that 5%, and it's like a tenth of the storage, so it's a tenth of the cost. But Adobe, your ex-employer, is working on this product called Firefly, in which they're sort of journalizing this whole thing. Like basically, you'll input a bunch of pictures, and then you'll give a prompt, like do this with these pictures, like this person. So that kills all the ideas with this concept, right? And then let's generalize this. It sounds like it's like an ultimate API contest where like everyone's trying to build like this generalized, powerful thinking thing where you basically prompt, here's what I want, and you will get that. So my question really is like, here's a dream of solopreneurship, but here's this fear that like these powerful tech companies with like their GPUs and their computational power and the direction in which they're heading is like more generalized problem solving. Like, how do you think about this? Like, I'm in conflict. Like, is it like a futile effort to even approach this part? Unless you're like thinking of getting acquired, like build something in the short term. Like, but what if you want to do like a meaningful pursuit where you want to dedicate the rest of your life? Like I have like 25, 30 years more of more work remaining.
So, sorry, are you saying, I'm trying to understand, are you saying that the big companies are gonna take over all the popular use cases and there will be nothing left for small...
Yeah, that's my fear. Like that's my worry. Is this the right way of thinking it? Like I'm telling you what I'm thinking through, and I want your opinion on this. Like, is there a right way of thinking about it?
I think it depends on the use case. It's very possible that like big companies will dominate because one of the things we discussed is limitations of training data. Like one of the main ways in which your model is more powerful than someone else's model is because either it has more training data or it has more compute. More compute meaning more parameters, more complex model, etc. Training data is increasingly getting locked down, I think. In fact, one thing about Adobe is this guy that I listen to, Ben Thompson, I don't know if you know, Stratechery, he talks about this a lot. He did an interview with Adobe's chief product officer, Scott Belsky, and one thing they talked about was copyright violations and image generation models, and Adobe is very much doubling down on their model, Firefly, being like a safe alternative to Midjourney, because Midjourney is not safe.
Who knows what training data has been involved?
Exactly.
You might get in legal trouble. So
in the sense that it's legally not safe. Like, but it's not clear right now whether the...
So you're saying... Sorry, go ahead. I don't want to interrupt.
I was saying it's not clear right now whether the legal standard should be applied at the layer of input or output. That itself is not clear. Like, if I take some, say, Marvel, okay, as an example... Can I take Marvel movies and images as input to my training data? Is that valid or not? I don't know, because current copyright law does not specify that.
Our current laws are not designed to understand like this technology.
Yes, exactly.
Or they were written in a time where like technology like this didn't exist.
It's very clear that at the output layer, it's prohibited. If I start outputting images of Iron Man, yes, that is very clearly prohibited by copyright law. I cannot do that.
Yeah.
That is clear. But at the input level, it's not clear. And actually, what Ben Thompson was saying is that companies like Adobe are trying to argue for a more restrictive version of the future, where they're trying to say that, hey, your input has to be heavily restricted. You cannot even get...
Wait, okay, help me understand this, because my knowledge may be limited because of what I understand from this. But isn't the problem with these models like the problem with internet in general? Like, once they've been trained, the cat is out of the bag. Like, once you've trained a model on the internet, it's done. Like, we have sufficient data that's already been generated on the internet to like have these models already trained. Like, Midjourney is there. Like, what are you going to do? It exists. And like, you can copy, like, okay, Midjourney is a closed source, but there are like OpenJourney, which is an open source Midjourney, like ChatGPT, for example, right?
I think the question is not about the model. The question is, can you commercialize the output of the model or not? That's the main question. As an output of this model, I got a video or an image.
But you yourself said that, like, even OpenAI does not know what it's been trained on. It's like there's the problem of explainability.
Yeah,
and so as you, like, is there a way right now to determine from the output of a model what training data was included in that model?
No, there's not. But I think we need to answer, is there a legal need to even clarify that question?
But because from what I'm hearing you say, and based on my discussion, you're saying like one possible competitive advantage you might have as a solopreneur or any business might be your training data, right?
Like, that's what companies like Adobe are trying to argue. Actually, Adobe is trying to argue that, hey, like, you need to train only on legitimate data sources. You need to train on like stock images or non-copyrighted images. Like, if you train on copyrighted images, that's not legitimate. That's in Adobe's interest to make this argument, because they own a lot of like stock images that they can train on, and Midjourney doesn't.
I know we're talking specifically about images because of the example I used, but
the same applies to text. Like, if I train on text from blogs, books that are copyrighted, is that a copyright violation or not? Like, no one knows.
Yeah, it's just the way you describe it. Let's say it does come into fruition. It sounds like a better version of the solution will be trained on everything. A suboptimal version of the solution would be restricted in its training. And eventually, I feel like our tendency would be to opt for the better solution. We'll figure out, like, the laws will align to that. Everything will align to that.
Yeah, I'm not sure if the laws will align, though, because right now, think about where did a lot of training data came from.
I'll tell you, the argument that you're making is when Uber came to India in a lot of cities, they were saying, no, let's figure out a way to keep the taxi drivers employed. And they were trying to figure out all these ways on making Uber worse, so that the taxi company stays uncompetitive. That's one way to go about it. But eventually you'll realize that that's a futile effort, because if there is a possibility of something more awesome, like, our tendency is to go towards that.
But I think the analogy breaks down in this way, because, like, Uber, for its existence, does not depend on taxi companies. Whereas like these AI models, for their very existence, depend on individual like content creators.
That's another good topic that we can discuss.
Yeah.
These models right now, as I understand them, they require a huge amount of training data. We humans don't.
Yeah.
Right? Like that's like this question's coming from like the evolution that we discussed, that like once we hit a wall with our machine learning based solutions, the way we found the next breakthrough was to emulate the way humans worked or human mind works. Now, if you take that analogy further, or if you take that solutioning further, then like we don't require a lot of training data. Like if you had to compress that into like bytes,
we can understand like concepts.
Yeah.
If you tell me a concept, I can understand it with very little data.
Yeah.
Whereas a model needs like tons of examples.
Right.
Yeah.
So I mean, it's not far-fetched to think that the next evolution would be a massive reduction in the training data required to get the same or better output quality.
It's possible.
Yeah. Then what? Like so my original question remains is like, is this like a winner takes all type deal where it's futile for like the dream of solopreneur? That's why I said solopreneurship. I'm not saying.
So I think actually this is a good point to distinguish. Like, what are the different? We're talking about entrepreneurial opportunities in the market space, right?
Yeah.
Like, let's define the different market segments here. So there's, on the one hand, I think classically right now, VCs and people are dividing this into 3 or 4 market segments. There's hardware, that's the base layer. NVIDIA.
Right. Google with its TPUs.
Yeah, they're providing the hardware layer. That's number 1. Number 2 is foundation models. That's like the large language models. OpenAI is the main player right now, but like Google, Meta, and other companies are getting into that space. So that's 2 layers. The third layer is the application layer. We're like building on top of the foundation models, like you're building specific applications. I actually don't know if there's a fourth layer or not.
That's the thing, the application layer.
Yeah.
I feel like the foundational model layers are going to consume the application layer, which and the reason I worry about that, even though I'm not like a solo entrepreneur, like I don't have any product, but I've seen this happen, and this has been a big complaint against big tech companies, right? Like without getting into the specifics, a lot of times people will like develop extensions for browsers or like some app which consume Facebook APIs or like Snapchat APIs, and then eventually what happens is Facebook just creates that product themselves, removes API access, or let's say it doesn't even remove it.
Facebook is not at the model layer, right? That's the application layer.
Yeah, I'm saying the model itself will generalize so much,
but it's fundamentally not possible unless the model can have access to Facebook or Google's data.
No. In this analogy of like the model, your application is some specific use case that uses the model and then enables that use case. I'm saying the model itself will become so powerful and so generalized that you don't need the application layer. It'll eliminate.
But I need specific data. We talked about like access to knowledge, external knowledge and data, right?
Yeah.
Like it needs access to my.
That's just one use case, and that can be solved with plugins. Like, why would that enable any more business use cases than hey, like this
actually, like the plugins question is more complicated. Like, why would if I am say
like imagine OpenAI, right?
No, I work for Facebook, right?
Yeah.
I work for Meta, so my company owns WhatsApp. Why would WhatsApp release a plugin for OpenAI? That doesn't make any sense. Why would Facebook want to give OpenAI access to like all WhatsApp messages?
Why would Facebook want to give OpenAI access to an entrepreneur? Here we're talking about like the business opportunities, right?
I don't think this will ever happen. I don't think Meta is ever gonna like make a plugin for OpenAI. I
understand that, but I'm saying with that same logic, Meta would also not expose that API to any solopreneur or an entrepreneur who wants to create a business.
No, that already exists. There's WhatsApp for Business. There's a WhatsApp Business API. You can use it to create like automated messaging. You can create a store. Like, you can do a lot. You can, like WhatsApp is used to run.
Okay, let's stick with that example. Let's say there's this API.
Yeah.
And I use Meta's LLM. Like in the future, let's say Meta comes with their own ChatGPT LLM.
Yeah.
And then I build some application. What's to stop Meta from making the LLM so generalized that eliminates the need of this particular application. That's my problem. Like,
what is the particular application you have in mind?
Whatever it is, like I'm saying, eventually the prompting to ChatGPT will be so generalized, that they itself will act as an everything application. But it'll be multimodal. Here's the thing, like it'll be multimodal. So your input will be multimodal, meaning it could be like text or image or whatever, and the output will be multimodal. And when you have multimodal input and multimodal output, all you need to do is just generalize the application layer, and then with text, I can say, here's what I want with this input, and here's the output.
I think it'll ultimately come down to like what data sources and applications you can plug into and integrate with. Like, I think that will be a big differentiator. I don't think GPT will, like, there's OpenAI, there's Google, Microsoft, Facebook. They all control different applications, and I don't think
these will still be the players. I'm not saying I'm like these will go away. What I'm saying is, like, my original question was, like, as you and I, let's say we want to explore like some business ideas over here. And it's not just like, hey, let's create something and hope that we'll get acquired or like acqui-hired or whatever. Like, let's create something durable, enduring. Like, I want to devote the next 25 years of my life. But like the way I'm thinking about this is, eventually whatever I do will be generalized within those foundational models.
But I guess like what I'm saying is, if the thing you're doing requires access to some specific knowledge base, like that is not something that can be absorbed in a foundation
in
model.
that case,
it like will we talked about
no,
this,
no,
right?
I know what you mean. But I'm saying, in that case, let's
like, where is this knowledge base?
Yeah, I understand. So let's say I build a company that uses some special knowledge base, and I obviously want customers, right? And my customers will actually have this special knowledge base. It's not that I have. I'm saying, what stops these LLMs to create like a general interface? Like, hey, as a customer, you going through this, cut the middleman out.
Oh, that is ChatGPT plugins, exactly.
That's what I'm saying. Like the way I see these things evolving, you're saying ChatGPT plugins and AutoGPT. I am thinking that the need, like, increasingly, I see the tech world going into a direction where it's cutting the middleman from everywhere. Like, it's famously described as your take rate is my opportunity. Like, what that means is, like Amazon will say that, hey, looks like hey, you were selling something, you're paying the retailers 25% margin. That take rate is my opportunity. I'll sell it for 2.5% margin. So I'm gonna like cut the margin by like that my take rate by an order of magnitude. I'll just take 10% of what your existing retailers take and come to my website. So I'm saying that like, if you just generalize it and like take it further, it sounds like everything's going to a direction where there'll be one prompt, multimodal prompt. Here's what I need. Here's my data. Here's the output I need. And that, like, the foundational model will do that. Like I said, I've been grappling with that because ever since, like, we've been discussing this for a while. Like, we just happened to have this discussion in depth today. But I've been thinking about this for a long time, and I'm like, oh, I have this fascinating. Like, Monica had this fascinating idea. It's like, oh, I'm gonna come up with like this AI stylist who's gonna do this and that. I'm like, I see it working really well now. But like, I'll always be living in like this existential fear that, oh, like because I can't build the foundational models that empower this business. What is to stop these foundational models just generalize it to a point where they just consume my business?
Because I think like your business is based on a knowledge of your specific customers, their requirements, their workflows, which the foundational models are like, I understand language in general. And you're trying to specify that and come up with a very specific application to a niche use case. So I don't think that will be disrupted. What's a good analogy to this? Like, it's like, that's like saying, like, because cloud computing providers exist, like, application layers will become irrelevant. That's not
it's
true.
Different this time. Like, I know it's you can't always use that, but I think it's different because the thing that we're dealing with has an agency, has intelligence. Like, I'm using words that you used in our discussion. What's the goal of AI? Let's go back to absolute basics. To delegate human intelligence to these systems. What is the most evolved product that we discussed today? Has a sense of agency.
Hugging GPT.
Now you combine those two, dude. Like, there's a system that has a sense of agency, has like unparalleled human intelligence. Like,
But like the thing is, there are a bunch of models out here that is using. These are kind of commoditized.
Yeah, open source. Like these are like available open source. Like
yeah, but like the open source versions may not be good, and you need some close.
It's going to design its own. Again,
but like, there's proprietary data. Like I think that's the thing.
I understand. That's what I'm saying. The ultimate customer will have a very simple way in submitting their proprietary data. And the model for that is plugins. Like you explained it to me and I understood what it means, like plugins.
But I think different types of proprietary data need different types of plugins, and like the type...
You generalize that even, like multimodal plugins.
I'm not sure, but what is the task ultimately that you want to do? Each task requires a different type of data access.
That's what I'm saying, like stuff like Agent GPT or Auto GPT comes in. Like I have a multimodal plugin where I'm like, I need this done. And the Auto GPT will figure out like, okay, I need to, like, let's take the basic example of mathematics and calculator.
Yeah.
I want to multiply 1000 into 1644, right?
Yeah.
Like I can't do this right now.
Yeah.
But it'll figure out that it's a mathematical problem and here are all the tools that I need.
Yeah.
And maybe there's an opportunity to develop these sub APIs, but I'm saying like what is to stop it from writing those APIs even?
Okay,
like calling more agents.
Here's one of the ideas that I've been exploring, which is like, I want to help people write their resumes.
Okay. Let's talk about that. Yeah, let's talk about specific examples.
Someone has a resume.
Yeah.
And they want to improve it. And I have been thinking about like, hey, can I generate like an AI-based agent that can help someone improve their resume? So how would that be genericized? Like what I want to do is take someone's resume, help them understand like what are the weak points in their resume and help them develop that. And right now, like if we put it through this Hugging GPT system, it might find some open source models that can do things like find your suitability to a particular job or like your like skills suitability or whatever, but maybe there are better specific models to do that. Maybe for specific domains, I could have specific data that helps with that. Like if you are applying for resumes in product management, like maybe I have a database of product management resumes that I could use to specifically optimize that. So yeah, in that context, maybe can you help me understand like what your fear is from a like I don't at all see
in the short term, maybe not. I agree with you. In the short term, yes. But if I extrapolate the advancements that are happening in this technology at an exponential scale, then your business is competing with like this exponentially increasing intelligence, and whatever you're going to bring, like fine tuning the algorithm. Can you keep up with this thing that like has gone from figuring out home prices and oranges and apples to like this thing?
So I think there's always going to be like the general version and the specific version, and I think the foundational models
can I challenge that premise? Is there always going to be?
Yeah.
Is there always going to be? And I mean, I don't know. Like you're most likely you're right.
Yeah.
I think there's a very good chance that you are right. Like I'm yeah. It's just I actually want to prove myself wrong. Like this fear that I have.
So I think there will always be a need to fine tune the generic version to a specific version. Like I don't think it's possible that you can say I've come up with the generic version of something that is like absolutely fine-tuned to any specific use case. Like, because if I say I want to write a resume, I want to write a college application, I want to write an email to my friend, these are all like specific applications. So it's possible what you're saying though, that like maybe some generic...
No, it's a great discussion.
And that's AGI, artificial general intelligence. Like this thing is so intelligent.
MVP in the like the way you describe it in your product manager world, like a minimum viable product already exists.
Yeah, ChatGPT.
No, Auto GPT, like this thing.
Okay.
Like this is the MVP to an AGI. That's insane.
Yeah. There's an MVP
in 2023, right, and the MVP for AGI already exists.
And it's Jarvis or Hugging.
Yeah, like, and they're naming it like Jarvis and making it sound cute, like Iron Man, whatever. But the thing is, it already exists. So if you take that exponential scale, like this thing's gonna get smart. But I take your point. So you're saying one area of exploration for a lot of entrepreneurs could be like this fine-tuning. Let's define it by a simple word, fine-tuning.
Specific domain knowledge. Fine-tuning actually has a specific meaning within the language model world, so I wouldn't use that. But I would say like application to domain specific application.
Yeah. Okay. Yeah, let's hope that that's the
domain
case.
knowledge.
Because otherwise, and I can think of other competitive modes that you can have. Like this seems like a good one. I hope that remains. Because if that goes away,
knowledge of like process, pain points, like I don't know, the classic like entrepreneur stuff.
I'll explain. Maybe I want to explain it better. Like, what's my worry? Ever since you told me about the subscription of ChatGPT, where you can use the ChatGPT 4 model, it's insane. I've not been as impressed by technology since internet. Like I remember like 20 years back when I first discovered internet, that's how I felt about it. And that's like the feeling that I'm getting now. And it's super smart. And if this is in 2023, then I've also started thinking about this like from my daughter's point of view, like, right? Like when she's 18, this what would be the level at which this technology would be? So like maybe hopefully in the next 18 years, it will still be the case that fine tuning or like finding your domain knowledge and processes will still define your competitive mode.
Yeah.
I have a fear that it might not, because you're competing with something which is exponentially increasing its intelligence, human intelligence.
And this is what people are saying. Like there are people that are very worried about this, and they're saying this is AGI and this is going to put all humans out of their jobs, and we have to have universal basic income, and there's no more jobs for humans to do. Like all of this is possible. Like, yeah, I don't know. I don't have a...
I think this is a very good place to end this discussion. We don't know. Like, I think that no, this is the perfect place. Like, we don't know.
Yeah.
Who knows? But as of now, in the month of April in 2023, this is where things stand.
Is it April or May? Oh, okay. It's still April.
It's still April. We're heading towards May. Dude, thank you so much for this fascinating conversation. I'm so glad we did this.
I really enjoyed this conversation.
Like this is great. Like we're sitting in like outside in California.
This is one of the longest conversations I've ever had.
Yeah, but this is so much fun, and I'm so glad we did it.
Yeah.
I hope whoever's watching, if they ever watch, enjoys this.